This meeting is being recorded.
Good morning, everyone. I'll just give a couple of minutes or a little bit longer for people to join before I start. Assuming everyone can hear me okay?
Yes, I can hear you.
Excellent, thanks. Okay, right, it's 9:31. I think we can kick off. So good morning, everyone. Thank you very much for joining us today. My name, if you don't know, is Lucy Morgans, and I'm the Programme Manager in the Electric Safety Policy Division of the Office of Energy Infrastructure Safety, or Energy Safety. I've taken over from Melissa Samsa, who's now Deputy Director. So we're here today to hear from the small multi-jurisdictional utilities, the SMJUs, and the independent transmission operators, the ITOs. So that includes in total Pacifical, Liberty Utilities, Bear Valley Electric Service, or BVES, Horizon West Transmission, and Transbay Cable. And we're here to hear from them on topics related to their 2022 Wildfire Mitigation Plan updates. And the key aim here is to engage in open discussion and questions from stakeholders and members of the public. So I want to thank you all for joining and for your participation and engagement in the Wildfire Mitigation Plan process. I'm now going to hand you over to Adrian Ownby from Energy Safety to discuss the workshop agenda, objectives, and logistics. Thank you.
Good morning, everyone. I think we can go ahead and head to the next slide. So we're going to start off this morning with a brief safety message. I want to remind everyone to be aware of your surroundings, stay hydrated and cool, to know your evacuation routes, stand up and move around. This is going to be probably 7 to 8 hour workshop, so you'll want to do that. Remember to practice your public health guidance. It's appropriate for your location. And if you feel something, please say something. We want to know. Next slide, please. So for those in the public who are new to California's Wildfire Mitigation Plan process, this is kind of a simple summary of what WMPs are. Electrical corporations are required to prepare and submit wildfire mitigation plans, WMPs, to energy safety for review and approval. WMPs describe how electrical corporation is constructing, maintaining, and operating its electrical lines and equipment in a manner that will minimize the risk of catastrophic wildfire. This is the third year in a 3-year cycle. Next year, we expect new wildfire mitigation plans from all submitters with the expectation of repeating another 3-year cycle. Next slide, please. So this particular slide includes a lot of important information for you as a participant, as a public member of the public. Docket 2022-WMPS is your primary source of information regarding the 2022 WMP updates. This is also the docket that you will submit public comments to, and you can see the address for the docket right there. However, we also have data requests, or DRs, that occur throughout the process. Utilities are required to post all data requests from energy safety and other stakeholders to their websites. The utilities have been instructed to file weekly summaries of DRs that have received that week to the 2022-WMP-DRS docket. That's the second docket listed there. So if you've not signed up for the appropriate listserv for these dockets, I would encourage you to do so. You can do that through our website. Next slide, please. So I think, as Lucy mentioned, the objective here is to provide an opportunity for the public and stakeholders to ask questions about key areas of the 2022 WMP updates. We expect to hear from the 5 small multi-jurisdictional utilities and the independent transmission operators. Next slide, please. So the workshop structure and agenda is pretty straightforward. We have 5 subject panels throughout the day. They're going to be 40 to 60 minutes each. There'll be short utility presentations followed by stakeholder and public comments, followed by any open discussion and additional Q&A. As Lucy mentioned previously, the utilities attendants are Pacific Core, Liberty, Bear Valley, Horizon West, and Transbay Cable. There'll be morning and afternoon breaks and a 1-hour lunch period. Next slide, please. So for the morning agenda, we're going to, you're in the middle of the introduction, which will be over very shortly. Then we'll have a panel on grid design and system hardening, followed by a break. And then we'll do a risk assessment and mapping panel. And then we'll have a lunch break. Go ahead, next slide, please. And then in the afternoon, we'll have a vegetation management panel, public safety power shutoff panel, take a break, do an asset management and governance panel, and then end the workshop essentially with an open discussion period where we can, field questions on anything that was talked about today. And then there will be a very brief wrap-up slide on the next steps. Next slide, please. So just some really quick logistics here. We're kind of committed to keeping this thing rolling on time. And want to emphasize an important ground rule for the proceeding, which is that comments and questions should stay focused on what's being presented. You should definitely feel free to use the Zoom Q&A function and go ahead and raise your hand during open discussion. Next up will be a brief introduction by one of our subject matter experts, Andy Biggs, who will introduce the grid design and system hardening panel. And James, if you could go to the, oh, no, not next steps. If you could go to the first presentation and next in the panel, and Andy will do the introduction. Andy?
Hi, good morning. I'm Andy Biggs. I'm a utilities engineer in the safety policy side of energy safety. And I'll be moderating today's first session on grid design and system hardening. Grid hardening is one of the main WMP initiatives, providing more permanent solutions to a changing environment to reduce or eliminate ignition risks. Between underground and covered conductor and a multitude of pilot projects, utilities should be evaluating and designing solutions to address their highest risk circuits. With that very brief introduction, I'll turn it over to the utilities, starting with Amy McCluskey with Pacific Core.
Good morning. Thanks, Andy. Good morning. My name is Amy McCluskey, and I'm the Managing Director of Wildfire Safety and Asset Management at Pacific Power. This morning, I'll be reviewing our 2022 grid design and system hardening update. I am joined by a few colleagues on the phone who may help with the questions portion, but I'll be walking you through our update this morning. Next slide, please. Great. So as Andy prefaced wonderfully, grid design and system hardening generally translates to long-term investment in more resilient systems. These investments help mitigate wildfire risk, and they also mitigate impacts of PSPS. So for 2021, Pacific Power installed approximately 20 miles of covered conductor through the line rebuild program, which also included 87 pole replacements. This progress will really help us protect our system against the impacts of incidental contact, which in turn reduces the risk that the electric line can become the source of a fault or a spark. We also completed the installation of 32 reclosers and relays to facilitate a system that can react quicker when a fault does occur. These devices provide for increased capabilities, such as more sensitive settings and elevated fire risk schemes. To mitigate the impact of PSPS, PacifiCorp also initiated both a generator rebate program and a free to the customer portable battery program for qualified purchases and customers. These programs were modeled after some of the programs available at the large IOUs and provide for alternate sources of generation during emergency type events, such as PSPS events. While more closely tied to dynamic risk modeling, which my colleague will touch on in the later panel, I will note we also installed 21 additional weather stations as we continue to grow our weather station network and support a more granular, detailed approach to risk forecasting and assessment. Moving into 2022, so what's different? We are increasing the initiative targets for weather stations, covered conductor, pole replacements, and system automation equipment, those relays and reclosers. As well as adding a few new programs, which I will touch on in a subsequent slide. We're pursuing a contract management strategy to support program delivery and this ramp up that we're trying to tackle. And we're also looking to incorporate undergrounding on a case-by-case basis. As far as beyond 2022 future plans, these include the continuation of grid hardening with a goal of completing our planned projects in the PSPS zones in the next few years. And continued risk-based expansion beyond these PSPS zones phased across the next 10 years, we estimate around that timeline. Next slide, please. As previously stated, grid hardening is all about long-term investment to build more resilient systems. So these resilient systems mitigate both wildfire risk and impacts of PSPS. As an example, covered conductor physically prevents the initiation of flashover due to vegetation or other incidental contact, which tends to be one of the largest risk drivers we have. So we're really focused on how do we mitigate that risk. In doing so, the mechanical properties of covered conductor also reduce PS impacts by making our system more tolerant of these risk events, reducing the likelihood that we need an event, and helping reduce the size or area of PSPS as sections or projects are completed. Therefore, when we're trying to figure out what to do when and where, grid hardening projects are targeted at these PSPS zones and generally phased based on risk to be able to buy down our risk quickly. I've got an example of how this works. We've put the Dunsmuir PSPS zone on the slide. So that's all the images on the right side of the screen. This grid hardening plan in the Dunsmuir PSPS area includes a total of 32.9 miles of covered conductor, which were broken up into 6 smaller projects, which you can see in the different colors on the map as you go top to bottom. These projects were generally grouped by circuit to support quicker delivery, allow for multiple circuits to be constructed at once, and support risk-based phasing where practical. Additionally, when planning or grouping these projects, we also had to consider potential construction constraints because they can kind of dictate how fast you can move or where you can move. For example of how this works in kind of prioritizing and phasing our projects, the 8.4 mile section on the south end of the PSPS zone carried a lower risk score than the other circuits. It also presented additional construction challenges requiring different permits, longer lead permits, and additional coordination with the state park. Therefore, it was planned for construction after the other projects so that we could prioritize based on risk and provide for this additional permitting time. As a second example, circuits 7G1 and 7G73 out of Dunsmuir substation, which are shown in the zoomed in portion on the slide. These projects are nearly complete, except for a few I-5 crossings. These projects were prioritized based on risk, so we've made significant progress on them. However, the crossing sections do require additional permitting. Therefore, they were grouped separately and have been phased separately to accommodate the additional time it takes to coordinate and construct those sections. In general, for the Dunsmuir PSPS zone as an example, we've completed 5 out of the 6 relays and recloser projects and 16 miles of covered conductor. An additional 8.5 miles are currently under construction, and the total scope is planned for completion in 2023. Once completed, the Dunsmuir PSPS zone will be more tolerant to risk events, mitigating the impact of PSPS. Next slide, please. So now that we've walked through a detailed example, I want to talk a little bit big picture about what 2022 will look like. We're implementing 2 new programs pertinent to grid hardening. One is the expulsion fuse replacement program, which is separate from the line rebuild program and targets the HFTD based on risk. In 2022, we plan to replace approximately 2,269 expulsion fuses with non-expulsion type fuses. Additionally, by the end of 2022, we're planning to have approximately 500 new communicating fault indicators operational on key circuits in the HF2D where elevated fire risk settings are likely to be used. As the use of these settings and schemes can result in more frequent customer interruptions, these fault indicators improve fault locating capabilities and support faster restoration to try and limit those impacts. And while fault indicators may not fall under the traditional grid hardening topic, they do reflect additional investment and underpin our ability to implement other programs, such as advanced protection and control, in a balanced way. As far as changes to targets in 2022, we're planning to install 51 relays and reclosers, which is up from the 36, and rebuild approximately 112 miles of overhead lines, primarily with covered conductor. These lines are highlighted in the image on the right. They target PSPS zones and follow the general methodology described on the previous slide. Next slide, please. Additionally, in 2021, Pacific Power is evaluating the use of underground on a case-by-case basis as part of the line rebuild program. Generally, underground is traditionally more expensive than covered conductor and cost prohibitive. However, in certain circumstances, we're learning that the cost of underground can converge with the cost of covered conductor or provide additional long-term benefits. These locations tend to be areas of heavy tree canopy with limited access, where underground can provide incremental benefits, and overhead lines present additional access and maintenance challenges. Or potentially high elevation locations where covered conductor is more likely to require full pole replacement and therefore be very expensive. Potentially other areas of low customer counts where underground can be lower cost because of the low number of customer connections, and areas with constructability challenges where permitting or existing infrastructure doesn't allow for cost-effective use of overhead lines. Examples might be culturally sensitive areas. So far, as a part of this effort, we've identified two portions of two different projects as underground candidates, which are shown on the slide. Keeping in mind this represents about 2% of the total program, so it's still a very small percentage. For both projects, the existing overhead is depicted in red, and the proposed underground equivalent is shown in green. For the Weed project, which is on the upper left-hand side of the picture, we've identified approximately a 1/4 mile to underground in lieu of overhead covered conductor rebuild. This was based on the existing right-of-way and surrounding infrastructure. There was not a good, straightforward, cost-effective way to install covered conductor without using very expensive self-supporting poles in residential areas. And so therefore the Highway 97 crossing there is being converted to underground. As a second example, the Mount Shasta project, which is on the right side of the image. This is an area where Pacific Power collaborated with the U.S. Forest Service and Caltrans to understand the access and permitting challenges associated with the existing overhead infrastructure. This section identified for conversion, which is the red line on the diagram, is located in one of these high elevation, heavy vegetation, low customer connection locations. So it tends to be a great candidate for underground. Additionally, the existing section is also located within a known cultural site where construction and permitting is challenging and not desirable. So at the advice of the U.S. Forest Service, we're now planning to relocate that red line to the green line and co-locate approximately 6 miles with a new communication line and ski lift in an existing trench that is already planned. Next slide, please. Looking forward, Pacific Power is also planning to bring on board a construction partner to improve project delivery. Currently, the internal PMO is managed by only a handful of employees, which is a great structure, but does present a challenge when delivering a high volume of complex construction projects in such a dynamic field. Many of the elements of these projects, which do contribute to the challenges, are listed on the slide, but include things like engineering, design, permitting, stakeholder engagement, environmental surveys, materials management, and construction, just to name a few. While still in the early stages, we intend to issue an RFP in the coming months. And once on board, this partner will help us staff up, adapt to changing circumstances and new information, and bring consistent expedited delivery of projects. This is something that will become even more critical as we look to continue on with our PSPS mitigation plans and continued expansion of grid hardening beyond these zones, beginning in the 2023 and 2024 timeline. And with that, that concludes my grid hardening presentation for today. Thank you very much for your time, and I'll hand it back to you, Andy.
Great, thank you so much, Amy. Next up, we have Liberty with Rick Dalton, Blaine Ladd, and Elliot Jones.
Hello, I'm Rick Dalton with Liberty Utilities, Senior Director of Engineering. We will tag team as we go through the slides and give you a brief overview of our system hardening efforts. And if you'd like more details, that they're contained in our WMP that was previously submitted. If I could go to the next slide, please. So first, I'll start with an update of our 2021 efforts. We, in 2021, we had more than our share of obstacles to our program, such as wildfires, and we completed a bit less than we originally wanted to, but we completed 4 major covered conductor projects, which I'll talk about our covered conductor program a little bit more in just a minute. We also replaced a significant number of poles throughout our system due to a number of programs going on. We replaced more poles than normal. In 2021, we replaced 211 poles, most of which were replaced due to findings during a complete system survey that we conducted in an effort to up our reliability of our system. And we continued our program for poles per test, and due to fires, we replaced, in addition to the 211 poles, we replaced another 175 poles as we rebuilt areas of our system after fires. And in our covered conductor projects, most of the poles, or many of the poles in each project, are replaced as we increase the structural capabilities of our lines. We are also systematically replacing equipment throughout the system. 2 of our primary programs are replacement of expulsion fuses and removal of tree attachments. On the fuses, we did approximately 857 in 2021, and in our years to come, we intend to do approximately 1,500 per year. With respect to tree attachments, we are focusing on the highest fire threat areas of our system and our risky dead and dying trees as far as which tree attachments to attack first. And our goal, our target is at least 45 per year. We're also improving our substation infrastructure, both by rebuilding and improving substations with more modern equipment, but we are adding animal guard equipment on all of our substations. We've completed, or will have completed by the end of this year, our 6 largest substations, and then next year we intend to add animal guards on 6 smaller substations. We're also replacing things like oil circuit breakers at our substations. We are also exploring and piloting a lot of other new technologies, which we'll talk about in just a few minutes. And we do have other programs such as cameras and open wire, gray wire, secondary replacement, things like that. Can we go to the next slide, please? With respect to cover conductor, we've done approximately 11 miles of cover conductor in the last 2 years. And in this year and the next year, we intend to do an additional 15 miles of cover conductor that consists of 12 projects. The projects range in size from a 1/4 mile to as big as 3 miles. And when we look at a project like that, we always evaluate various alternatives. What is the best method to harden our system in this area? Is cover conductor best? It is tree wire style cover conductor or the ACS bundled cover conductor the best for that situation? Or is there another alternative such as undergrounding or essentially conventional strengthening of the system, or for that matter, in some cases, there could be an opportunity for a microgrid to be installed instead of needing to improve a line. And we found that when there is a relatively small load at the end of a long line, that is the most likely potential for a microgrid. And we've looked into that, and we've actually installed one microgrid and have another potential site that we're in the process of preliminary design and figuring out if that's going to work for us. We've also used cover conductor to create resiliency corridors. We've completed one early this year that involves a resiliency corridor that can be fed by a diesel generator set that we have at the Kings Beach area. And that's our first resiliency corridor that's been completed. And we have an additional one that we're planning to complete by next year. And may we go to the next slide, please? As far as emerging technologies, I would like to kick it over to our Director of Operations, Blaine Ladd, to share a bit about what we're doing in this area.
Okay, thanks, Rick. So as far as emerging technologies, there's a few things that we're working on here at Liberty. Rick mentioned microgrids. We did successfully implement a microgrid in late 2020 that serves one small customer, and that enabled us to successfully de-energize a 4-mile section of line for the entirety of the 2021 fire season. We're also looking and studying other areas where we can implement further microgrids solutions. For distribution automation, we're starting a pilot program this year. This will increase sectionalization options and reduce scope of PSPS events, leveraging existing and new field equipment, and help us improve reliability during emergency scenarios. For grid topology, it's mainly based on behind the meter battery energy storage. So we have a pilot program where folks can sign up and volunteer to have a battery in their house, and that'll provide power during PSPS events, fires, other emergencies, storms, etc. And also, as Rick mentioned, we're looking to add more resilience corridor feeders where where we use covered conductor to feed down to underground sections of commercial areas and try to keep those energized during PSPS events. There's also distribution fault anticipation, which is the Texas A&M incipient fault detection technology. We're implementing that on 5 of our feeders this year. For high impedance fault detection, HIFD, we're currently collaborating with the University of Nevada on a study for HIFD and hope to implement some of that later this year. And then also fault detectors or fault indicators, using those to better detect where faults are during more sensitive fire season settings on some of our devices, breakers and reclosers, etc. So, and that concludes our presentation on grid design and system hardening. Thank you.
Okay. Thank you so much, Rick and Blaine. Next up, we have Tom Chow or Paul Marconi with Bear Valley.
Hi, this is Tom Chow from Bear Valley Electric Service. I'm the utility engineer and wildfire mitigation supervisor. Next slide. So what we have accomplished so far, that we have upgraded our Palomino substation. It was one of our older substation that we converted from overhead sub to an underground sub. We have conducted our covered conductor pilot project, which we tested 2 different type of conductor, 394.5 AAC and 336.4 ACSR covered conductor. Since end of 2021, we have replaced 20 miles of circuit miles of covered conductor from bare wire to covered conductor between our 34 kV system and our 4 kV system. And in addition, that we had an evacuation route pilot program that was completed. We tested out the wire mesh wrap around the wood pole. We also tested out fire resistant composite poles and lightweight steel pole, just to see which ones we prefer. And we are using both depending on the type of construction that's out there. We have installed on the pilot project 5 lightweight steel pole, and the fire resistant pole we have installed roughly 9 poles, and we're continuing to install those. We also implemented our route hardening program, which where we have 3 main routes that come up to the Big Bear Lake area. And we had either started already wrap wrap poles with the mesh wrap. And we will be completing that by end of 2022 fire season. Next slide. In addition, we had installed 20 weather stations throughout the whole valley and 15 cameras that was installed at 7 locations. You could view it at the Alarm Wildfire Network. Will provide the coverage of the Bear Valley area. In addition, we have started 2 years ago the fuse replacement project, which we completed it last year by eliminating all of our expulsion conventional fuse throughout the whole valley with L fuse, current limiting fuse, which is the same as L fuse, and our electronic fuses, which we use as our trip savers. And that's so we're done with that program. Next slide. In 2022, our initiative and targets that we're planning to do is install fault indicator throughout the valley between our 34 kV and 4 kV system, which will allow us to track where if there's a voltage that's happening throughout that area and hope restore power as sooner than later. We're continuing to install covered conductor throughout the valley. The plan is to install 12.9 miles throughout between the 34 and the 4. But our main focus is on the 34 kV line, and any underbill within the 34 kV will be done at the same time. One of our main feed, that the Radford line, we are planning to replace those poles with fire resistant poles and installing cover conductor from the connection point from Southern California Edison to Bear Valley Electric through our the Forest Service area. The thing that we're waiting on is the permitting from the Forest Service. That's what's holding the project right now. In addition, while doing the cover conductor throughout our valley, we are assessing 225 poles this year, and what we assessed last year, we're planning to replace 165 poles. We started our tree attachment program a few years ago, and we're continuing to remove any tree attachment throughout the valley. And our target for this year is to remove 80 tree attachment removal. As I mentioned about the wire mesh that we're doing, we're going to be finishing up with the evacuation route, and our target is to wire wrap 412 poles. And we are planning, last year we have completed our fiber loop installation throughout our valley, so we could connect our SCADA project through our devices that are in our substation, and also going to work on starting to install devices out in the field. Our plan this year is to connect 3 of our substation to our SCADA network, and next year we'll install three more and following, and continue until we finish all our substation that are connected to our SCADA project. Next slide. Does anyone have any questions?
Thank you, Tom. We're going to keep questions to the end.
Okay.
Yeah, thanks so much for the presentation. Next up, we have Jennifer Cheney with Horizon West.
Hi, good morning, everyone. I'm Jennifer Cheney, and today I'm going to talk about Horizon West. Horizon West is one of only 2 ITOs in California, both of which are owned by NextEra Energy. Just to level set, this project is different than what, we've heard from the rest of the presenters. It only consists of 1 operational asset. It's a single station with a static bar compensator, so it's really there just to provide grid support. It connects to a San Diego gas and electric substation via a 1-mile 230 kV line. It's located about 40 miles east of San Diego near Alpine, and it is in a high fire threat district. And actually, could we go to the next slide? I'm sorry. So this is just giving a few of the facts about the station. So really, because it is in that high fire threat district, and we have had a fire that was within about 3 miles of the station before, we started our hardening the site in 2020. And I did want to mention, particularly after watching some of these other presentations, that we do have some remote monitoring capabilities. We have a weather station as well as cameras on there. So next slide. In 2021, we completed over half of our anticipated hardening efforts. We really focused on two areas: the station, specifically the transformers, and the overhead section of line. In the station, we were concerned that catastrophic failure of the transformers could result in a fire in an adjacent area. So we took steps to prevent a failure by adding seismic pads underneath the transformer. And then we looked for ways to contain a fire should one occur. So we did this by adding a fire barrier around three sides of the transformer, as well as adding flame suppressing stone to the oil containment pit. We completed all these activities for one of the two transformers in 2021. So switching to the transmission line, there was one section of the transmission line that was overhead, which we undergrounded in 2021, as well as now we have an associated monitoring system on it. Go ahead, next slide. So for 2022, the initiatives are really, really similar. The plan is just to repeat the transformer mitigation on the second transformer, and we're near complete with all those initiatives. But we're really continuing to monitor trends in the industry and looking for ways to further mature our wildfire mitigation plans, despite this being, really just a single asset. Next slide. And that concludes my presentation. Thank you.
Great, thank you so much, Jennifer. And then last we have Michael Blunt and Raj Prakash with Transbay Cable.
Yes, hello, can everyone hear me?
Hi, yes, we can hear you.
Excellent. Hi, so my name is Michael Blunt and I'm the operations manager for Transbay Cable. I'll be giving you just a brief overview of the Transbay Cable Wildfire Mitigation Plan update and talk about our grid design and system hardening efforts today. I'm joined by Raj Prakash, our environmental health and safety manager here at Transbay. Next slide, please. So Transbay Cable's operating territory is limited to three elements of critical infrastructure that supports the Greater Bay Area grid. We have a high voltage DC converter station and transmission line that runs from the Pittsburgh converter station. It's in East Contra Costa County through the bay to San Francisco at our Potrero converter station. Next slide. So our transmission line is obviously submarine cable that's buried in the bottom of the bay. And for our fire risks, we observe these fire risks near the Pittsburgh converter station with approximate vegetative fuels located near us right here in the city of Pittsburgh. And then as well as our proximity to seismic fault lines. And next slide. Now, our TBC system design provides inherent system hardening against the wildfire risks that we observe. Our substation facilities include underground transmission cables. All of our transmission is underground on the AC and the DC side. They're buried, they're encased in concrete. So at our substation, all of our outdoor above ground equipment is fully contained within the converter station walls. And we've got a hardscaped facility that's protected by the 12-foot concrete perimeter walls. We also have implemented the fire department approved fire lanes and Knox box key boxes for fire department access to the indoor areas of the facility in the event of an emergency. Our indoor converter is also equipped with the monitoring and detection features, detects fire or trouble events and automatically de-energizes the facility in the event of a problem. And our system is monitored and controlled by our transmission system operators. They have access to manual emergency shutoff buttons that are located in each control room at each one of the substations and in our primary control center. So in the event of an emergency, we can just push the button to turn it off. So we also have the transformer blast walls and containment pits with the the rock in the containment pit to sort of squelch any oil if it's on fire in the pit. And all the pits are designed with 110% capacity, so more than capable of containing a whole transformer worth of oil. All right, next slide. So here at TBC, we completed our transformer seismic hardening project in 2021. So we installed the seismic base isolation system underneath our main power transformers. I've got a picture here, a diagram on top that shows sort of the mechanical arrangement of that base isolation system, and then a picture showing what it physically looks like. You'll see our main power transformer sitting on top of a white concrete slab, and then the base isolators underneath. They're made here in California by Earthquake Protection Systems, and they allow our transformers to ride on what's called a friction pendulum bearing. This allows, during a seismic event, allows the ground to move under the transformer while the transformer sits on top and experiences reduced G-forces, and therefore it reduces the risk of having a failure, oil rupture or bushing failure on the transformer. So this engineered protection system also includes uplift calculations, and that prevents transformers from being tossed or heaved off their foundations during a seismic event, and prevents the internal electrical faults and failures. So during this installation, we also increased the height of the fire protection walls that the transformers sit in to accommodate new height of the transformers from setting them on top of these base isolators. In 2022, TransBay will continue to sort of enhance our system hardening efforts and reduce the operational risk, including the fire risk to our system, all in the name to ensure the safe and reliable transmission of power. And next slide is the last slide. And I just want to say thank you very much for your time. That concludes the presentation for TransBay Cable on the grid hardening and design.
Great. Thank you so much, Michael. And
thank you.
Thank you to all our presenters today. I wanted to turn it over now to our panelists to start the Q&A. So we're going to start off with Matthew Carl from Cal Advocates.
Hi, Andy. Good morning. Thank you. I think I'd like to start with a question about let's start with egress risk. I know that Bear Valley talked about it, but I'd like to hear from the other utilities. Have you identified areas of egress risk within your service territory? How are you identifying those areas? How are you quantifying that risk? And how is your utility planning to reduce egress risk through system hardening and other programs?
Hi, this is Amy. I can start for PacifiCorp if that works. So yeah, I appreciate the discussion from Bear Valley around egress. I would say I don't think we have that as a specific element we consider in grid hardening plans. We don't have that same sort of matching program that Bear Valley has. What I would say is that, the way we're targeting grid hardening is it's all about supporting PSPS mitigation, kind of supporting risk tolerance of the system. In theory, should result in fewer needs for egress, but there's not a direct tie. I would say where it comes into play is more in the emergency management realm, kind of the decision-making realm, and we're typically getting that feedback from our public safety partners. But right now, there's not a direct program or a specific link between kind of egress route planning and how we're planning our grid hardening, if that makes sense.
I think if we could hear from Liberty as well.
Hi, this is Rick Dalton with Liberty, and we consider egress as a factor in our hardening, but have not found specific areas that are obvious that need extra work. We're targeting our tier 3 HFTD areas primarily and considering egress, but as of yet haven't found specific areas that require immediate action or even that trump working on the core areas that are our highest risk areas.
Thank you.
Great. Want to turn it over to GPI to ask any questions, and then we can come back to you, Matthew. Just want to give time to others to ask questions first. Or is someone from GPI on? Not hearing anyone, I'll go ahead and ask one of the questions they submitted in advance. Let me see. Zoe Harold doesn't look like.
Andy, I'm sorry. There is a hand raised from the attendees, but I don't know if this is an individual you're looking to speak to now.
Oh, that's right. Yeah, it says Zoe doesn't have a way to connect.
So I can allow them to speak if you'd like.
Yeah, that would be great.
Zoe, you should be able to mute yourself.
Hi, Zoe Harold with Green Power Institute. Thank you, Andy. So thank you to all the SMJUs and ITOs for their presentations today. I guess I will start with maybe a specific question on whether PacifiCorp and Liberty are considering replacing their poles with fire-resistant pole upgrades like Bear Valley is.
No, excellent question, Zoe. This is Amy from PacifiCorp. We are, probably didn't come out in the presentation, the short presentation. So as a part of our line rebuild program, we design everything and engineer it to then take the new weight, if you will, of the covered conductor. And so where poles require an upgrade, we are taking advantage of that situation and upgrading them to more fire resilient materials, which could be, steel, fiberglass, not necessarily wrapped wood as often, but it could be any of those materials. And so we are, as we're going, and so we are reporting those targets in the WMP. So that is a thing we're doing.
And Liberty?
At Liberty, we are considering upgrading poles. We definitely upgrade them structurally, and we have piloted ductile iron poles, the intumescent wrapped poles, and steel poles, and we've installed those on a few and consider those on future projects. But it's, as of yet, it's not our norm. It's more in special cases where we would use those.
Great, thank you. And I do have other questions, but Andy, I'll let you manage with all the interveners.
Yeah, I think you'll have another chance to ask more, but did want to go to, there's one that got entered on the Q&A from Miles Gordon. PacifiCorp stated that in certain cases, cover conductor can converge with undergrounding in terms of cost. Does PacifiCorp have approximate cost per mile for cover conductor under normal circumstances, and in these specific cases, what causes the cost to converge in these cases?
That's a great question. I think I touched on it a little bit in the slide, but I can expand on it a bit more. As far as average, so we've got about 20 miles under our belt of covered conductor, and you see a big range. Our average cost there is probably around $600,000 a mile. We've seen, as low as 300 and as high as 1 million. So it just kind of depends. General factors that are driving that huge variation, pole replacement, where we're either at high elevation and we need to design around high elevation loading cases. It means the poles need to be upgraded. It means all the poles need to be replaced. Things get very expensive. Conversely, underground, I think in general, we see an average, and like I said, we don't have a ton in this program, but we have some experience in other areas where we've installed underground. Around $2 million a mile is generally average. So if I take the average covered conductor and the average underground, there's a big range. But as that covered conductor gets more expensive, or we have to do more pole replacements, or we run into permitting challenges or actual construction challenges and access, underground can become more comparable, because underground can also get cheaper when things like customer connections are very low, or we have existing infrastructure, such as the project I talked about, where we're taking advantage of an existing trench and an existing partner project. So there are some things that can bring down the construction costs underground. It's not everywhere, but we are finding there these unique cases where our normal 600,000 compared to 2 million is actually becoming more like 1 million compared to 1 million. And so you're starting to see that there's incremental benefit in that underground. I'm hoping that helps answer the question.
Great. Thank you, Amy. I'll turn it back over to Matthew with Cal Advocates.
Thank you. I guess continue with undergrounding. I know Pacific Core went into quite a bit of detail, but I'd like to hear from the other utilities where you're planning to employ undergrounding. What criteria are you applying in sort of making the decision whether or not to underground a line?
I can speak for Bear Valley.
This is Tom.
Go ahead.
Oh, go ahead, Paul.
We have no major undergrounding projects right now. And mainly it's a cost-effective issue. We have a lot of hard rock up in Big Bear Lake. So that does drive the cost quite a bit. We also have a lot of uncertainty with the Forest Service areas and getting permitting. It's really just a big cost-effective issue for us. That we do small, a lot of new projects, new additions. We do, the city or the county do encourage undergrounding for new developments. And we do evaluate those a little differently. So when there's a system expansion, that is an opportunity for undergrounding, but in general, we don't right now.
I'll comment for Liberty. We do have, and we have done and are continuing to do significant Rule 20 undergrounding projects. And on our system hardening, we always consider undergrounding, and we do small portions of undergrounding on specific cover conductor projects when we need to deal with things like access or scenic issues or permitting issues. And so we do have a small amount of undergrounding going on just for system hardening in addition to the Rule 20. And we have never found undergrounding coming even close to being, less than double the cost of covered conductor. So it hasn't, been a cost-effective solution for us for system hardening in general as of yet.
Thank you.
Okay, and then I'm going to hand it back to Zoe with GPI.
Hi, thanks, Andy. So I'll actually follow up on that question from Matthew. And Liberty, can you provide a little additional detail on Rule 20 and basically the selection of those projects, and then how that fits in with the mitigation planning? Because those projects seem to be in some of your lowest risk regions.
You are correct that they're in lower risk regions. I must say, though, that our entire system is a high risk area. Our entire system is either tier 2 high fire threat district or tier 3. In general, a section in South Lake is tier 3 and everything else is tier 2. So we have significant threats throughout our system. And we comply with the Rule 20 with respect to the local government getting credit for warranting the undergrounding projects, and in the primary reasoning behind those projects is things like the scenery and to a lesser extent wildfire mitigation, but they do address our system hardening. But again, that's not the driving reasoning behind doing those. It's basically what the local governments are pushing for, primarily for beautification.
Great, thank you for filling that in. I have more questions, but Andy, whatever, however you want to.
Yeah, let me ask the one in the Q&A. Also, as a reminder to any of the other attendees to please feel free to use the Q&A function. This next question is from Charles Madison. I'm assuming this is to all utilities. What underground construction technologies are being explored for your programs? Examples given being open trench, cable and conduct, or directional drilling.
Andy, for Pacific Core, we're looking at a combination of directional drilling and open trench. Keeping in mind we're still talking about 2 tiny projects, so it's a pretty small amount, and it is very unique circumstances where we're seeing underground make sense. But those are the two tactics that we're looking at.
This is Tom for Bear Valley Electric Service. If we are going to do underground for new facilities area, it would be an open trench with conduits, and then install our underground cable.
At Liberty, it's primarily open trench with selected areas where needed for directional drilling. And I want to mention that we do have significant issues with hard rock and dewatering needs and so on in many of our areas.
Okay, thank you so much. Turn it back to Matthew, Cal Advocates, assuming you have more questions.
We do, thank you. Sort of on the same note as the last question, can the 3 utilities describe their typical covered conductor installation? I know that Pacific Core in the past was using spacer cable, for example.
Sure, I can start again. So right now, the projects we've completed are spacer cable. That has been the primary method. I would say in some of the other states we work, where we have wildfire mitigation plans, we've been gaining some experience with tree wire. And certainly trying to learn through the different working groups in California. It sounds like a lot of different companies are experimenting and trying out different tactics and tools. I think we're hoping to kind of open our tool bag a little bit and consider more alternatives. We've been primarily spacer cable just to get some comfort and experience with it. In California, I think we're looking to try and expand and potentially use tree wire where it makes sense, similar to how we're starting to evaluate underground on a case-by-case basis. I think we're just learning there isn't necessarily a one-size-fits-all, and so we want to make sure we're open to the new information and things we're learning from the other utilities. But so far, progress has been spacer cable.
I'll comment for Liberty. At Liberty, we're using both the spacer cable and in some cases the tree wire. And we are deciding between the two systems primarily based on access and concerns by our crews on repairing the ACS wire in areas where you, for example, can't get a bucket truck to the wires. And in those cases, we would typically opt for tree wire. But we're basically using those two systems and about 50-50.
This is Tom. For Bear Valley, we're using just cover conductor wire, and we're replacing basically like for like. For example, if it's ACSR, we would replace it with the same cover conductor and then install on cross arm, because our spans are usually 150 feet spans throughout the whole valley.
Thanks, everyone. Can I ask for the non-engineers if you could define tree wire?
I'll just say that tree wire is basically your standard wire, but it has insulation on it. So it's the same wire, but it's bigger, thicker with insulation, and it's much heavier. So that you need stronger poles and cross arms and shorter spans.
Thank you.
Great, thank you. I'm going to give it back to Zoe.
Great, thank you, Andy. So I believe perhaps my last question, because a lot of them have gotten answered. So the expulsion fuse replacement programs are slated to take multiple years, I believe, for Pacificor and Liberty. I think Liberty had a 6-year timeline for complete replacement. So I think my first question is for Pacificor, how long do they expect that expulsion fuse replacement program to take? And then in the selection process of locational prioritization, when those replacements are being implemented, is it happening essentially as the same time as other grid upgrades like covered conductor replacements, or is it being prioritized separately based on your risk maps?
Sure, so I can answer for Pacificor. We just kicked off the program, the expulsion fuse replacement program. Generally, we're expecting it to complete in 2023. We're working as hard as we can. The big driver for that time is actual engineering time. So these fuses are really important for coordination throughout the circuit. So unfortunately, it's not as easy as run up to the pole, pull one out and swap one in. There's a little bit, a lot more design time. So some of the projects that require more design time take longer, but in general, we're trying to complete in 2022 and 2023, so 2 years. As far as the phasing, when we do the line builds, we do replace the expulsion fuses. And just what's new for us this year is making sure we're also, as separate projects, replacing everything else. And so that is prioritized based on risk outside of where there's coincident work with the line rebuild program. And that's what's new for us this year. We were doing it already under the line rebuild program, but now we're tackling it separately to move faster on the other lines.
And Liberty?
What specifically, can you repeat your specific question, please?
Yeah, so actually I'll even expand it a bit. So I believe your fuse replacement program is anticipated to take 6 years. So what efforts are being done even in the interim over that 6-year completion timeframe to reduce risk in high risk areas? And then is that work basically being implemented coincident with your covered conductor replacement program, or is there another effort to prioritize those fuse replacements independently or in addition to existing grid hardening work in high risk areas?
Thank you. We're on all projects, we're putting the non-expulsion fuses in when we do those projects. We also have a separate program that standalone where we're replacing the expulsion fuses. And you're right that we have a 6-year plan. We have focused on the tier 3 area as the highest priority, but we also are doing them scattered around the system. We're tackling the easier ones first that don't require much engineering. And it does take work to do the design work, get them done properly, and our plan is to keep with our program at 1,500 per year, and so that we can complete within the time frame we've talked about.
Great, thank you.
Great. And then turn it back to Matthew Carl, if you have any more questions.
Sure, we have a couple more. I think Bear Valley touched on this, but I'd like to hear from the other utilities. Does your utility have conductor attached to trees as part of your distribution system within the high fire threat district? And if so, do you have any ongoing programs to identify and remediate those existing tree attachments?
Sure, thanks for your question. We do have a few tree poles in our service territory. They tend to be on secondary service. They don't tend to be on the primary lines. I think we've got maybe around 100 kind of scattered throughout. As far as a proactive program, we don't necessarily have a proactive or separate program. We kind of tackle it a couple of ways. As part of our inspection, correction, standard asset management programs, we do identify them and we flag them for opportunity maintenance just because they're on the secondary side, so they're not typically carrying the high risk distribution lines that you might normally think of. The other way we might tackle them is through the line rebuild program. So should they be attached to primary lines, we would replace them as part of that program. I mean, we're certainly, open to considering additional programs to replace those poles because we do see there's value in that. Just as far as prioritizing work, if I'm prioritizing a line rebuild program, it means I'm prioritizing the highest risk area, which means I'll catch the highest risk ones first. And as far as kind of proactively replacing the remainder of them, that's something we might consider after we finish the high risk circuits.
Thank you, Amy. If we could hear from Liberty on that.
Yeah, it looks like Rick might have frozen up, so I can take that. We do have tree wire attachments, and like PacifiCorp, they're primarily, I believe all of them are secondary, so low voltage covered wire attached to trees, and we do have a program to remove those. I believe our target is 45 this year, and that's going to be continuing over several years. There are issues that slow the process down. Primarily, it's getting easements for new poles to set on customer property, which tends to slow the process down significantly. But yes, we do have a program to to mitigate those.
Thank you. And as a follow-up, I guess for all the utilities, do you have records comprehensive enough to identify the tree attachments on your system, or are there attachments you may or may not be aware of?
This is Tom from Bear Valley. I believe roughly 5 years ago, we did a full GIS of our system. So we have pretty much, I would say 99% knowing where they are, and we are tackling them as we get to them. And yeah, we have a system.
I think we're probably a mixed response. I would say we have some good records. We started cataloging these as part of our inspection program a few years back. So we have been able to collect quite a bit of information on where these configurations exist. So I feel fairly confident, but I'm sure it's not an exhaustive assessment. You know, we didn't send someone out to every pole to take a look. It's been more of an, as we visit the pole, catalog it and understand where it is.
At Liberty, we've surveyed our highest fire threat area, the Tier 3 area, and but we do know that we have many tree attachments throughout our system. So our approach is to, again, target the highest fire threat area and target the trees that are most at risk, dead and dying trees, for example. And we also address them on our various cover conductor and various replacement projects.
Okay, thank you. Matthew, did you have any more questions? I think we have time to take one more. He'll go a little bit into a break. It's an important discussion, so.
I think that's everything that we had prepared, but if we could elaborate a little bit on discussion in the last question, more generally than tree attachments, how are the utilities finding equipment on their system that maybe wouldn't have been thought of as a fire risk 10, 15 years ago, similar to maybe a tree attachment, but is considered a fire risk now? Do you have comprehensive records of what's in place on your system, and where you don't, how are you looking for these, you know, known unknowns or unknown unknowns?
That's a great question. It's a tough nut to crack, if I'm being honest. But no, that's definitely a challenge we have is, you know, legacy records, unknown records, records that maybe aren't quite detailed enough. They might say, hey, you have this thing, but not the 17 items I would actually want to know about the thing. As far as how we're improving in that area, generally through inspection programs, as far as identifying risks, correcting conditions. So I think we're seeing a lot of movement in that area. We're starting to collect more information when we inspect. So example is the tree poles. That's something we started years ago on, hey, we need to know about this thing. We need to start collecting it. So that's one area where we see improvement. As far as learning about new risks, I think the biggest place where we tend to get more information is through evaluation of our risk events, risk data, ignition drivers, and honestly, learning from other utilities. To me, a great example is the expulsion fuse program that we've just kicked off this year. It wasn't something we traditionally thought about as being a risky piece of equipment for us. It's been standard, it's been okay, starting to learn, oh, this piece of equipment isn't quite what we want in our high fire risk areas. And so started to kick off a project, learn that from other utilities and, you know, at the advice of the energy safety. As far as doing that, once again, didn't have the greatest of records. So we did have to go through and make some assumptions, and we're just working at circuit by circuit and saying, I know I have this many fuses. I'm pretty sure it's this many expulsion fuses. Let's go through and clean it up circuit by circuit and work my plan. So that's one way we've tackled the lack of, I would say, inventory as we learn about a new risk. Hopefully that helps. I'll let the other utilities chime in if they've got something different to add.
This is Tom from Bear Valley. You have hit it pretty much on the spot. And as we go through the inspection, if we find something and something that we could update in our GIS, we would add it to it. Other than that, that's all I have.
This is Rick from Liberty. I'll just mention that because our records were not as good as we would like, that was one of the reasons for doing a complete system survey of our system in 2020, where we collected more information than typical, and based on, and we had a focus on looking at things from the wildfire mitigation perspective and looking at things like CAL FIRE exempt hardware and what's out there. We that greatly improved our records on what we have, and also generated a large amount of work for us to address all the issues being found. And once we're complete addressing those issues, we'll have made a major step forward in our system hardening.
Thank you so much. And we got a follow-up question in the Q&A from Wendy Benedetti. Bear Valley stated that they did a comprehensive cataloging of their assets. Where are the other SMJUs in that process? We kind of touched on that.
Yeah, so for Pacific Core, we don't have a plan or a program to do a comprehensive evaluation or cataloging of assets. The service territory is pretty broad. It's pretty complex. Instead, we've kind of been, focusing resources on going circuit by circuit and mitigating them. So there's kind of a couple different, ways you can get there. You can do an inventory, which tells you where do you have things and how do you work your plan. We've taken more of we know we need to mitigate this circuit. Let's go assess it, see what's out there, and then mitigate it, which is how we've been doing the expulsion fuse replacement program, for example. But we don't have a plan to do a system-wide inventory that Bear Valley was mentioning at this time.
At Liberty, I just want to mention that when we did our survey and subsequent to that survey, we are using a GIS-based system to collect lots of information about our assets. The initial run, we actually corrected the positional accuracy of our assets and documented significant amounts of information about the specifics of what's there at every pole and what needs to be addressed at every pole.
And then, so you had your hand raised?
Yeah, thanks. So just to follow up on some of these responses and a thought, there's this movement away from basically run to failure operation modes. And so I'm curious if for Pacific Core, where there isn't this territory-wide basically database of all of your systems, are you building that database then as you do the circuit by circuit assessment to then be able to track or, basically depart from a run to failure type grid hardening approach?
That's a great question. And I probably should have, maybe I've understated what inventory, we do have an inventory of components. So for example, I know where my poles are, I know where my circuit breakers are, I know where my lines are and the voltages and things like that. It's more I can't tell you the make and manufacture of the tiny subcomponent of the widget. I think that's where, we don't have that kind of information. Not to say we couldn't get it, or others may have different variations of that information, but we're not typically haven't historically, I should say, tracked at that level. We do have a database and a system, and I'm saying as we've kind of increased our capability as far as commissioning new assets, tracking replacement of assets, the database is growing. So if I were to look at, subcomponent widget information on something I constructed in 2020 compared to something I constructed in 1970, they're going to look very different. So we are able to increase the tracking over time. So that is getting better. We're just not doing it through a system-wide inventory process. As far as run to failure, we've started to look at a couple of different things. The main focus probably hasn't been quite as much through overhead line hardening, like the tactics we're talking about today. They've been more substation based around your key equipment that you can't afford a failure. You need backups, you need redundancy. So a lot of your big long lead items. So we've started to do some work there around how do we measure and predict failure and replace ahead of time. On the overhead, we've been mainly exploring, are there different tactics to assess more? So less of, age-based replacement, but more of can I use an infrared inspection to diagnose something I can't see with the naked eye that gives me a little bit more of a lead time on how it's performing. We're also looking at things like DFA technology to try and assess failure before it happens. So we're definitely making moves. It's just not necessarily through an inventory system, if that's helpful.
And sorry, did that answer your question?
It did, thank you.
Great. I think with that, we'll go ahead and start our break. We're going to keep it at 10-ish minutes, so meet back at 11:05. And thank you so much to all the panelists for the great questions, as well as the utilities and the presentations. And next up, we'll have risk assessment and modeling.
Okay. Well, it's 11:05. Is Andy back?
Hi, yeah, I'm here.
Okay. Why don't we go ahead then and get started with next presentations? Or after Andy's introduction.
Hey, yeah, so if any of you missed this morning's introduction, my name is Andy Biggs. I'm a utilities engineer with Energy Safety. I'll also be moderating today's session on risk assessment and modeling. Risk modeling should be the backbone of the utilities WMPs. Utilities should be evaluating the ignition, consequence, and PSPS risks that exist along their systems in order to understand where wildfire risk exists within their territory. This is vital for informing initiative selection and placement in order to maximize reducing the most risk as effectively and quickly as possible. With that, I'll now turn it over to the utilities, starting with Steve Vanderberg with Pacific Core.
Thank you, Andy.
Sorry, as a quick reminder that we're saving the Q&A portion till after the presentations, but encourage people to use the Q&A function in the meantime. So yeah, sorry about that, Steve. Go.
No worries, no worries. So yeah, I'm Steve Vanderberg. I'm the manager of meteorology here at Pacific Core, and I'm going to run you through some updates on our modeling efforts and risk assessment. So next slide, please. All right, so 2021 was a pretty busy year for us. You know, one of the first things we did was the procurement of some additional infrastructure, specifically high performance computing technology or hardware to support our modeling efforts. And I'll get into more detail on that here in a moment, but it's a key component of what we're doing in terms of our risk modeling. Another thing we did in 2021 was we went into a pilot with the TechnoSilva Wildfire Analyst software, which included Firecast and FireSim. And I'm sure a number of folks on this call are familiar with TechnoSilva's products, but in essence, it allows us to take weather forecast data and run wildfire simulations to map out potential wildfire risk and consequence across our system. And then another thing we did was we created version 1, if you will, of a customer and employee website that pulls in a lot of our weather information for consumption, like I said, by customers or employees. Primarily initially focused on weather stations, but adding a lot of model data as well. And I'll get into that here in more detail in a little bit. And then 2022 is shaping up to be another really busy year for us as well. So I mentioned our investment in the computing hardware to run our models. We're also creating a 30-year historical record of weather conditions across our service territory, and I'll go into more detail on that in a bit. We're expanding our weather station network. We have decided to continue with TechnoSilva's Wildfire Analyst Enterprise. We're going to feed it additional data, though, starting this year, including our own weather forecast model data. As well as, in addition to Firecast and FireSim, we're going to have wildfire risk reduction model. And we're also working with them to develop some additional tools for us, including a fire potential index, which I'll go into. We have a new team of meteorologists here. So including myself, now we're a team of 5 meteorologists. So that allows us to provide the 24/7 meteorological support throughout the fire season. And then in 2022 as well, we are planning additional installation of communicating fault circuit indicators. The timeline, you know, looking ahead, high level, right? So right now we are looking at completing that first round of analysis of a lot of our new historical data this summer. We hope to have our fire potential index, our first version of that, completed later this year. And then as we complete the final 30 years of historical reanalysis, that'll set up us well for doing additional analysis and refinements and improvements going into 2023. And then beyond that, we're looking at something called multi-member ensemble forecasting to supplement our single deterministic run of our weather forecast models. Just a fancy way of saying, instead of just taking one model solution, we're going to try and come up with a very smart way to create multiple model solutions, but that are configured in a way that allows us to look back at this historical data to really understand the probability of various impacts. So I know that was a lot, but again, I'll go into that here in a little bit more detail. And then, continued improvements, automation of a lot of this data to help expedite certain types of forecasts, et cetera. So next slide, please. So I mentioned the modeling. So right now we're running a 2-kilometer, 96-hour weather research and forecast model. This isn't just weather conditions, but it's also fuels information. So what we call NFDRS outputs, National Fire Danger Rating System. And so this is giving us a much more detailed look out 96 hours of the weathers and fuels conditions across our service territory. I mentioned the 30-year weather history or reanalysis. We're using this same model to create that 30-year hourly record so that we can, in essence, create the foundation for a risk-based forecast. So in other words, when we run our operational weather models going forward, it references the 30-year historical data to then give us a sense for the magnitude of the event. How unusual is it? Is this the worst we've seen? Is this something we see every year, right? And in addition to that, we will build and train machine learning models off of this 30-year data as well, which then get incorporated into the operational warfronts to better predict impacts. That could be outages, it could be wildfire occurrence, it could be a whole host of things. And then we, as mentioned earlier, we are expanding our weather station network quite a bit across our California territory. So we are planning to be at 80 weather stations by the end of this year in California. And that's going to give us 10-minute observations at a more granular level across all of our circuits in the HFTD. Next slide, please. All right, so I mentioned Technosilva's Wildfire Analyst Enterprise, and I know some of you are familiar with this product, but in essence, going forward with this, we are going to take our model data, we deliver it to Technosilva. They run millions of wildfire simulations using our model as the weather input, and then it spits out wildfire risk, consequence, potential, et cetera, so that we can identify where the greatest risks are across our service based on current and forecast weather conditions. But there's also the long-term piece of this, which is wildfire risk reduction model, which will help us understand or quantify, how the risk, what the risk looks like across our system and how it's changing as we update our information, as we incorporate our 30-year reanalysis. Right. And then the other thing we're doing this year is, as just like the big California IOUs have done in creating an FPI or a fire potential index, we're attempting to do the same thing this year. We're actually going to partner with Technosilva on this, and we're going to try and combine our 30-year historical data with our operational data with the outputs from their wildfire modeling software to come up with a very comprehensive index. And so we're in the early stages of that right now. Next slide, please. I mentioned weather stations and websites. So we do have a few new websites. The one that's relevant here for this conversation in this group is pacificpowerweather.com. And if you go there, what you'll see is the latest surface observations or weather station observations from not just our weather stations, but also from National Weather Service stations like ASOS, which is typically at airports, RAWS stations, which are typically owned and operated by fire agencies or like the Forest Service,
And it also includes Department of Transportation stations as well. So in this case, Caltrans. And we've gone ahead and calculated the climatology for the wind for all these stations using the existing period of record. So as we get into the top 5% of wind gusts that have been observed at a station, the data turns yellow, and the graphs show that as the yellow area on the plot. As we get into the top 1% or the 99th percentile wind gust, it turns red. And so this is something that's available not just to our employees here in the company, but also to our customers as well. And so that's the first iteration. We're continuing to make improvements. We do include model forecasts in there from both the Weather Service, something called the National Blend of Models, as well as the European model. And then here soon, we hope to be displaying our own WRF output as well. And you'll be able to see how current conditions actually compare to the forecast. And then going forward, what we're going to do, I mentioned again, the 30-year data and the building and training of machine learning models. We can then take this methodology and apply it to the historical record or the surface observations from all these weather stations, and then create bias correction for all of these stations, which could then, for future iterations, get included into this website as well. I mentioned we have 5 full-time meteorologists now, so that provides us the resources we need to provide that 24/7, 365 support. We're sending out forecasts daily to the company, and then we also do event-driven forecasts outside of business hours on the weekends, et cetera, as necessary. And then, of course, we support our emergency coordination center and operations in general. And then we are looking at some wildfire detection capabilities or technologies in combination with cameras for 2023. And so we are looking at locations that could benefit from this technology. And so that's coming in 2023. I believe that concludes my slides for the modeling efforts and risk assessment.
Great, thank you so much, Steve. Next up, we have Liberty with Cindy Fisher, Jordan Perio, and Chris Lautenberger.
Good morning, everyone. My name is Cindy Fisher from Liberty Utilities, and I'm going to be providing a general overview of Liberty's risk analysis and wildfire risk assessment. The focus is going to be on major modeling accomplishments made last year, and also future plans for refining our modeling. Chris Lautenberger from REACTS is also going to be joining the panel to field any of our technical questions. Next slide, please. So the map over on the right is Liberty's 2021 fire risk map. This mapping was based off of random simulated fires along Liberty's overhead lines. It also factored in fuel data, wind patterns, had a burn rate of about 6 hours, and also timbers and structures were factored into this modeling. And what it did was it estimated fire spread and damages related to those simulated fires along our lines. The results were summarized into the fire risk polygons that you see. There's different shading. So over on the west side of the lake, you can see is designated as yellow. And so that means it's low wildfire risk. Whereas the portions of South Lake Tahoe are denoted as very high wildfire risk. So everything that had, similar risk attributes were qualitatively assigned these different ratings. As previously discussed in the grid hardening discussion, our engineering and operations team use these risk polygons to target risky areas and to prioritize major grid hardening efforts made last year. Some major refinements to this risk assessment and mapping is that REACTS had developed an ignition rate model that Chris can, go into a lot of depth explaining. But what was interesting is that, now this ignition rate model is fully integrated with the fire propagation modeling, whereas before it was a separate analysis. And so the two models didn't really talk to each other. So having it integrated is a major refinement. To develop the ignition rate model, what REACS did was it used all of Liberty's historic forced outage data over the last 5 years. This amounted to about 1,300 risk events. And each of the risk events were overlaid with historic weather data. So at the time, date, and GIS location of the risk event, this information was used to develop outage rates per line mile. And all of the consequences of the simulated fires using the ignition modeling is now summarized at the circuit level and not at the previous polygon level. Next slide, please. And what this does is it makes it easier to model performance and also to model risk reduction at the circuit level versus, those weirdly shaped polygons. This information can be used to assess risk of vegetation contact. It could be used to assess fire asset risk at the circuit segment level. We could also use historic risk event data, so like all of our forced outage data at the circuit segment level, and we could identify certain risky outage types, and we can plan our future mitigations accordingly at this lower level of detail. And as Rick and Blaine mentioned, the system survey was conducted and completed in 2020. It provided a lot of valuable asset data that we can use to assess, overall asset health, risk of failure, and we can really target those future initiatives. We also have very detailed LiDAR data, which will be discussed in the vegetation management discussion, but this information can be used to assess tree risk at the circuit segment level as well. And that's the map that you see over on the left. Next slide, please. Okay, so some of the major changes for this year is to, really refine the analysis, take in, all of the great work that that REACS has conducted for us. We can really target these, risky circuit segments and really plan and target our wildfire risk going forward. So thank you. I think that concludes everything.
Great. Thanks so much, Cindy. Next up, we have Paul Marconi with Bear Valley.
Good morning. If you go to the next slide. So I'll just walk you through our broader picture first. As a SMJU small utility, we use a very basic overall risk modeling in accordance with the Commission Decision 1904-020. And basically we look at, it's a 7x7 matrix logarithmic, look at frequency and impact weights, look at a lot of mitigations. The problem with this one, it's not as, it's more qualitative, subject matter expert driven. Go to the next one. So out of that first model, you basically get for different mitigations. For example, let's say covered wire, you get what you would be a relative risk reduction or benefit, and also a risk spend efficiency. But what you don't get is exactly where to apply it. And so we developed this model here. It's still, the weakness is it doesn't have the probability of, the frequency of an event. And so, but what it does is it takes each circuit, it prioritizes, it categorizes them by the risk they are exposed to. And then when you apply mitigations to each circuit, it kind of keeps score of how much risk you're reducing. So some of the things that make circuits high risk is, for example, which area is it in? The high fire threat district, tier 3, tier 2. We look at the voltages, as a subtransmission or distribution circuit. We look at, is it bare wire? Is it covered wire, underground? We look at vegetation density. Now, initially when we started this effort, it was more SME driven. Now we actually calculate a corridor. It's a 12-foot corridor on each side of the lines, and we compare LiDAR surveys that we do each year so as to measure the vegetation density. And so that goes into this. So it's not, that part is not SME driven. We also did something similar with weather. Does the circuit have high winds, low winds? And so we had our weather consultant take our weather stations, and we developed some weather maps of wind probability, historical winds in those areas. And then we apply that to what percentage of the circuits is in each one of those zones. So it became a little more mathematical in the way we determined that. But like I said, it still doesn't have the probability of occurrence baked into it yet. All right, can you go to the next slide? One thing, though, that we did stumble on, I'll say, is, and that's why when we update the model, we actually go back and update it from the beginning. We started doing this in 2019, and so it's kind of a scorecard for us. And so it tells us where we've been and where we are today. And if we continue the mitigations, where will we be? And so it gives us a relative indicator of how are we doing on reducing the risk and applying the resources that we're applying to this effort. Are we getting the right results? So that's one of the nice things about this one. Go to the next one. So last year we engaged Reacts Engineering to provide us a capability that we didn't have in-house and developed risk mapping that was more quantitative driven and give us those assessments. One of the nice things about the results we provided is they pretty well coincided with what we expected, especially on when you consider fires for area. Now, we did learn some stuff on when you consider the impact on structures, where your higher risk circuits are, and that has to do with spread. It's not intuitive, and obviously where the structures are. So fire spread models are important, and that's something that our fire safety matrix doesn't really take into account. So one of the nice things that we got is one, an annualized burn probability, and that it was a good outcome for us to be able to see that and where to focus. The other piece that we got to really look at was current conditions, and then where are we in 2050 with climate change? And it basically tells you that if you think an area is good today, well, it may not be in good shape in 2050. So all your planning needs to also be, you can't just stop once you've fixed today's map, all the red on today's map. You got to keep looking as the map changes. And so, and sometimes that's really good for our projects because the way you sequence them, and it might be easier to just do, for example, on the North Shore, just do the whole North Shore instead of doing only these certain spans. And then if we could go to the next slide. So for 2022, we're also working with Technosilva. It makes sense for us to do that because of some of the products they offer, and also they do work with Southern California Edison, which surrounds our area, and so there's a lot of synergy in the models they've already developed for in working with Edison to just apply them to our domain area. And one of the things key about having a domain area is our infrastructure, let's say it was involved in sparking a wildfire, doesn't necessarily limit itself to our service area. It could actually spread out of our service area. And so that's why we look at a bigger domain area that is determined based on historical fire spreads, topography, and software prediction. And what we're looking to get out of Technosilva on these in this effort is, one, to get real-time or near real-time data that we can use in determining whether or not to invoke a PSPS. And so that will refine what we currently use, the National Fire Danger Rating System. And then we apply that to the actual local weather conditions. But I think what Technosilva's product gives us a much more accurate prediction there. The other piece is they actually are the ones who feed into the national NFRDS. The other piece that we want to do, and this is kind of a once a year thing, is they take our utility infrastructure and take a snapshot on where we are today in our mitigation. So, and we hope that over time we can get something similar to what we're doing with the fire safety matrix, and also be able to input. Let's say we give them a GIS file showing certain circuits are now covered. What's the risk? And so being able to predict that out in the future is good, and will really help us in our wildfire mitigation planning. And it also, I think, especially this software, I think will be helpful as we communicate with our partners in the community, city council and our district county supervisors on, where is the risk, and what are we doing, and are we really going to reduce it, and what makes us think we're going to reduce it. And so those are important questions to be able to answer and show them. So I think that's the last slide I had, and we'll take questions during the Q&A part.
Great, thank you so much, Paul. With that, wanted to turn it over to the Q&A. So again, a reminder for participants to please feel free to use the Q&A function, type your question and we can get it answered. Wanted to start off by turning it over to GPI, who's one of our panelists. If so, if you're available.
Hi, thanks, Andy, and thanks again to the SMJUs for their presentations. So my first question is very specifically relating to consequence. So we know that the general risk equation is probability of ignition times consequence. And these plans seem to essentially describe an estimating of wildfire consequence. We know that Liberty and Pacificor and Bear Valley all have match drop and fire spread models that are being conducted at a circuit level now. So that's great. And so my question is, what is the wildfire consequence estimation process? Is it qualitative? Is it quantitative? What all factors are going into that? And then how is that number, if there is a number, being used to basically determine risk in these risk maps?
So I guess Pacificor can start. So we're still very early in the implementation of this. And so those conversations are happening in terms of sort of quantifying the consequence in a sense that what's okay, at what point does this raise the level of concern, right? So right now it's more something that we're developing in terms of what do the exact numbers look like? What does when we're trying to quantify that risk associated with consequence, there's a lot of factors that we're still working through. So there's a bit of subject matter expertise that's built into this from a qualitative perspective, right? So I've been using Technosilva's tools for, oh man, I don't know, close to 7 years, something like that. So I'm familiar with the output, but I'm in a new environment now. And we're implementing it for the first time here. So we're still early in that process. There was some initial work done earlier that predates me, where there was some work looking at consequence in terms of downstream consequences of wildfire in developed areas and such, but that predates me. So yeah, we're going to learn a lot this year as we start pulling in this historical data and running all these simulations. We're going to learn a lot from that data, and that's going to help us move forward and make those determinations, I guess, in a quantitative way.
I can just give some background about how we've typically quantified consequence. There's a number of HVRAs, high value resources and assets that you can use to quantify consequence, but the three that usually dominate are, of course, structures, impacts to timber, and then sensitive habitat, if there is any in or near the service territory. And so typically what we have done is quantify the impacts to structures as the number of structures within a modeled fire perimeter, the impacts to timber as the number of acres of timber that experience crown fire. If it doesn't experience crown fire and only has surface fire, it doesn't get counted. And then for sensitive habitats, sage grouse, things like that, it would be a similar aerial tabulation. And then the utilities can decide how to weight those differently. It's a little bit of a deviation from what was done back in the California High Fire Threat District mapping process, which only considered impacts to structures. It didn't explicitly consider timber or habitat, for example.
I would just add, and since Chris did most of our modeling, his answer covers that, but we I would say the one thing that's, if you're asking this, I don't think we include the consequence of fatalities. So, and I'm sure our insurance companies do. The other piece is, I think we look at unsuppressed conditions, but we do have, and which is a valid way to approach it because it's the worst case. But, you know, for example, in Bear Valley, we have a big lake there. And generally in the fire season, helicopters are airborne almost all the time and in San Bernardino, and are generally able to get on a fire within 15 to 30 minutes max, once a plume's identified. So the scenario of going out to 48 hours is not extreme, is not likely. But still, you get a out of control fire, and so it's worth looking at that case.
Yeah, and just to add to that, there's some kind of subjective calls that have to be made with regard to how long do you model the fire spread for. As Paul alluded to, the fires are currently modeled as unsuppressed. There isn't a real good way to account for suppression due to differences in initial attack and extended attack across different areas. And then also fire spread models don't do a good job at modeling spread in really urban or built up areas. So they do okay in the wildland urban interface, but as soon as you get to a real built up area like Ventura, where the Thomas fire crashed into, or Coffee Park in Santa Rosa, where the Tubbs fire damaged or destroyed several hundred homes, that's kind of beyond the capabilities of current generation fire spread models. So it's an active research area that people are working on to try to figure out how to account for when you will or could have structure losses like what happened back in the Marshall fire in Colorado at the end of December, which was really more of an urban conflagration kind of a fire than a wildland fire. So when I say we tally the number of structures within the fire perimeter, it's limited to what the models can currently see and burn, basically. They don't burn into really built up urban areas, even though that can happen under very high winds.
Thank you. That's really helpful. And so then also for Pacificor and Liberty, Bear Valley, I know you mentioned that you don't have maybe like a population density component for fatality estimation. Liberty and Pacificor, do you have that component in your consequence evaluation?
Yeah, we do not. It's just structures at this time. Yeah, and I appreciate Chris's comments as well. I think he brought up a couple of really important points with regards to where the wildfire simulations can struggle and why quantifying consequence can be very difficult. And if you think about the worst events, the big events that we all worry about, consequence can be far greater than what the model may indicate. So there's always this element of subject matter expertise that comes into it, no matter how much you get very good at quantifying. And as we continue to move toward these advanced technologies and continue to put big data to work, there's still an element of subject matter expertise that comes into play, because when we get into these really big events, things tend to be a little worse than what the numbers may show, at least in my experience.
Yeah, and I'm not aware of any efforts, qualitative or published or otherwise, to actually quantify the number of fatalities in a given hypothetical modeled fire. I think that's probably beyond the kind of state of the science. If you look at some of the past large loss fires, a lot of times people are trapped while evacuating, or nearly trapped while evacuating. And so it's a function not just of where the structures are and where the people are, but also the time of day, and also the type of the characteristics of the population. Are there disadvantaged communities or people with mobility impairments, things like that? But I just will say that the type of things that are being done now are orders of magnitude more sophisticated than what could have been done 10 years ago, maybe even 4 or 5 years ago. There's really been rapid development and progress in this area, and it just continues year after year. So I suspect that what we're all talking about in a year or two will look significantly different than what we're looking at now.
Chris, yeah, I really appreciate your input on this. And so what I understand is basically in these kind of city and high population areas, the fire spread models are possibly even underestimating the impacts or the fire spread potential in those locations. Is that correct?
Yeah, if you model the Tubbs fire, it stops when it hits Coffee Park. It doesn't go into Coffee Park and burn any structures, because the inputs that are used for the fire spread model mark those high density built up areas as urban, which the fire spread models treat as non-burnable. And so there's a research project ongoing at UC Berkeley funded by the Gordon and Betty Moore Foundation that we're working on to add those capabilities to the current generation fire models. The California Energy Commission has also funded a project to address a lot of these limitations in the current generation fire models. So there's really a lot of research and development that has to be done, and we need help badly. So there will be good progress within the next few years. I'm confident of that.
Great, thanks everyone.
Yeah, thank you so much. This has been a really great discussion. Wanted to give others opportunities to ask questions real quick. I know Cal Advocates submitted some questions with Holly Orman.
Hi, yes, I'm Holly Werman, a utilities engineer with Cal Advocates. I was hoping all the utilities could go into a little more depth on their wildfire probability modeling. It sounds like each of the 3 utilities are using either REACTS or TechnoSilva or some other methods involving SME judgment to model or estimate fire consequence. But I'm curious how you're modeling fire probability, particularly, is this a machine learning approach, a regression analysis? How does it work when you have very few, or in Bear Valley's case, no ignitions in the past? So I'd be interested to hear each of the utilities speak to probability a little bit. Thank you.
Just to clarify, when you say probability, are you talking about just the overall probability of wildfires in general, or are you talking about the probability of electric, equipment like power lines starting a fire?
The latter. So if we're looking at the wildfire risk as a consequence times probability of ignition, I think the purpose of this exercise would be to model the risk of your system causing or contributing to an ignition.
Yeah, so with regards to the risk from our equipment, that really comes from our risk group. And I don't know if Amy, you're still on the call and you can help answer that, because that I think might be addressed by our local, our LRAM model, localized risk assessment model. That seems to really fit into LRAM there. And this will get incorporated into what we're doing with TechnoSilva. So, so there is a lot of work ongoing to bring what we've already done into TechnoSilva. One other thing before I hand it over to Amy is using the weather data and the historical data. You take the we've already started this process of taking the historical data, the reanalysis data, and correlating it to events on our system, i.e. outages. And we've created, in essence, what are fragility curves that basically show us the relationship between that model data and weather-related outages on our system. And so going forward, what we do is we take the operational model, which is of the same configuration of the reanalysis, and in a sense, the machine learning models reference the forecast, reference the work that was done to correlate past weather with outages to then give us in essence, an impacts forecast. So it takes those fragility curves and says, these circuits here, have a certain probability of seeing a weather-related outage today. So that's like a component of it, because there's still an ignition component to this, right? But when you talk about how do we know when there's the risk of a weather-related outages? How do we know when the outage risk is sort of above the normal baseline level that exists every day? And that's where the reanalysis data and the operational model comes into play. And so we've done 5 years. We're going to do 30 years. Obviously, outages from 30 years ago aren't going to be as useful to us in creating these models, but that's sort of a big starting point for us. And our early results are very encouraging because the configuration of these models is the same, it's an apples to apples comparison. And so even though there may be biases in that historical data, the biases are there in the operational model as well. And so it can tell us, hey, this is in the top 1% of forecast for the circuit, and based on 5 years of data and in history, or 10 years, you can keep going. This is your likelihood of an outage, or this is how many outages you could see, weather-related outages, assuming that the system in that location hasn't already been hardened or converted to underground or cover conductor or something like that. Amy, I don't know if you want to add to that from the risk side.
Yeah, I can. So hi, I'm Amy again. I think probably one of the reasons Steve paused about the question is it's not that we calculate likelihood or assess likelihood different. We just kind of have different tools, and whether it's a long-term planning view or a heat of the moment dynamic event decision-making view, we might layer on different things. And so what Steve was kind of talking about is the operationalizing of our kind of longer term risk model that tells us where to plan projects, tells us how to prioritize long-term work. As we operationalize that, it takes a lot of the, if you will, the likelihood, the probability assessment factors, and looks at them in real time and says, ooh, in the heat of the moment, how would I expect my system to react to this event? Kind of the basic model, which is what Steve was describing, this more LRAM, it is something that we've been evolving over time. It's kind of our Gen 1 long-term planning tool, and it looks at things like utility risks, is what we would call them, a utility risk layer, which I believe is getting at that likelihood of ignition piece. And it generally pulls together an outage event history to look for different ignition risk events like incidental contact with trees. It pulls in a tree canopy layer to try and give us localized information around fall-in risks. It looks at arc energy potential, which says, okay, if my system were to experience a fault, how much energy can be released, as well as utility ignition history, which is a tiny factor. So it kind of takes all of those things and says, here's my utility risk. It also layers in some environmental features, such as the longer-term climatological data, the kind of last 5 years fire weather patterns, and highlights locations that have experienced large fires in the past, kind of utility related or not, so more environmental in nature. Takes that utility risk layer, the environmental risk layer, and says, here's how I risk rank my circuits or my sections of circuits. That's more for long-term planning. But the utility risk pieces, which is things like the outage records, outage history, the long-term weather data, those all feed into kind of this operational view so that Steve and his team can say during the heat of an event, has my system historically performed poorly or well during this type of weather? And so you can kind of get an assessment of, would I expect a fault or would I not expect a fault? Because those faults are typically indicative of ignition risk events. So I'm hoping that kind of ties it together, maybe. It's a lot of words.
The other thing, I just want to add one thing to Amy and to sort of finish it off, is with regards to, in general, there's the risk of an ignition, but then there's the risk that that ignition grows into a wildfire. And so where a lot of the work we're doing in the meteorology side comes into this is taking that historical data, working with TechnoSilva, working with data scientists to then correlate that data or build and train machine learning models using that data and using historical wildfire occurrence, wildfire behavior, taking all the data that exists today, particularly in recent years, we have a lot more granular data on these wildfires. And because our service territory is so large, it goes, beyond California, we have a very large domain. Our 30-year data set covers a good chunk of the Western United States, which means we're not limited to wildfire occurrence and wildfire events in, say, Northern California. We have a lot of events that we can look at, which is really going to help us understand the conditions that lead to that ignition growing into a wildfire of concern. And so that's the other component of this that's really important, because it's not just about what's the probability of a failure in an ignition. And this is the whole, I guess, the consequence piece, right? It's if we have the ignition, does the environment support rapid growth, of that wildfire? Or is this going to be something that fire agencies show up and stomp out in a sense? So just wanted to add that extra little layer to the answer to explain how the meteorology side is coming into this, leveraging data science, TechnoSilva historical data, the 30-year historical data, wildfire occurrence, and machine learning techniques to get at that probability that the ignition becomes a problem.
For Liberty, we used a similar approach that involved correlating about 1,300 outages since I think starting in 2016, if I remember well, with environmental data, basically with wind speed and direction, relative humidity, temperature, all those surface quantities at the time and location of the outage. And then what you can do is compare that to the historical range of conditions at that particular location to show how much of an outlier were the conditions at the time of the outage compared to historical, and then use regression to develop estimates for the outage rate per line mile per hour as a function of really wind gust is the main one, but temperature is the secondary one. And so you see an exponential dependence of outage rate on wind gust, something like a factor of 10 to the 4 difference between 20 miles per hour and say 65 miles per hour, meaning for the same conditions, temperature, et cetera, you're about 10,000 times more likely to have an outage at say 65 miles per hour than at 20. And viewing outages as a proxy for ignitions, the same generally applies to ignitions. In fact, if you do a similar analysis with the CPUC reportable ignition data from the big three, there's about 3,300 or 3,400 ignitions, and those data correlate almost the exact same way, just with the NFDRS ignition probability replacing temperature. So it's this exponential dependence of either the ignition rate per line mile per hour or the outage rate per line mile per hour on wind gust that really feeds into the ignition component, because what that says is that you're most likely to get power line ignitions exactly under the worst case, or the exactly when you don't want to have them, under really high wind speeds. So that really, from my perspective at least, says that the consequence modeling should be coupled to the probability modeling, because the conditions under which you're more probable to have ignitions are generally higher winds. And so that's an improvement that Cindy mentioned to the modeling that Liberty had done more recently, is coupling the probability modeling to the consequence modeling through that wind gust component.
I'll just add, Chris did our modeling, so, but he also, like you mentioned, Bear Valley doesn't have any emissions in the database. So there's an assumption that we were just like the other California utilities. And so we use the database, the entire database there for California utilities. And I believe that was looked at over million years of fires simulated, so as to actually make it show up on the chart. Because you're right, the data is low, it's low numbers. So.
Okay, thank you all for going into more detail on that. I do have more questions, but I'll see if Zoe or anyone else has more.
Yeah, thank you so much. That was really great discussion. I'm glad we got both like the consequence and the ignition risk side in deeper detail. Did want to ask, we got one question in the Q&A from Charles Madison, asking if any of the utilities engaged with an independent consultant to audit or assess if their wildfire risk model is providing the best estimates of risk from ignitions caused by its own equipment. Or I guess also just in general, if any of the utilities use a third-party validation for their risk models.
So this is Steve at Pacific Core. So, you know, our generation 1 model, we're still doing a lot of the reviewing, right? So that process, I mean, we're so early in a lot of this, but we've seen what the other utilities across California are doing, particularly the IOUs, and the success they've had with TechnoSilva. And we've seen, obviously, Cal Fire is using TechnoSilva now. And so, and then, of course, I have experience using TechnoSilva products when I was previously at San Diego Gas and Electric. So all that just to say that we're following what we're seeing is the leading or the standard practice that the California IOUs. And so that was a big part of, you know, why we've gone the path that we've taken.
I'll add for Bear Valley, I think each step of the way we've used outside experts. One, just in our general risk-based decision-making process, we hired, I think it was Accenture. And then we hired Reacts for last year's work in developing the maps. And now we're embarking on some real-time simulations and weather monitoring with TechnoSilva.
Hi, for Liberty, we haven't done any outside auditing, you know, as far as our risk modeling goes. But we have on the asset side, so asset inspections, you know, we've had additional audits just on the inspection records, asset replacements and that sort of thing. But other than that, that's the extent that we have.
Okay, thank you. And I know we are now slotted to break for lunch. Adrian wanted to check with you if we should go ahead and break for lunch or keep going.
I think if there's any more questions, we can go ahead and keep going, and just start lunch a little bit late. You know, another 10 minutes wouldn't hurt if there's more questions.
Okay, I'll turn it back to Zoe first, if you had any more questions.
My first one will hopefully just be a really quick follow-up on Holly's question. Pacific Core mentioned having their tree canopy layers integrated into that POI modeling. Does Liberty also have tree canopy layer or tree density included in their POI modeling?
Currently, no, because the ignition location, or sorry, the outage location isn't really fine enough to know if what the canopy characteristics were. There's some uncertainty. And if I remember well, and Cindy or Elliot or someone correct me if I'm wrong, there was only around 100 ignitions involving outages involving tree canopy. I may very well have that wrong, but the short answer is no, not yet. We would like to.
Great, thanks. And then my next question is for Liberty. So looking at basically the HFTD tier 2 and tier 3 maps and kind of overlaying those with your wildfire risk assessment maps that go from low up to very high wildfire risk, it's interesting that there isn't so much overlap between your very high wildfire risk zone and then the HFTD 3 zone. They're somewhat overlapping, I think, from what I can tell, visualizing that overlay, but also kind of butting up against each other, and then seeing where a lot of the work is happening with pole replacements and fuse replacements. A lot of it is not necessarily happening in that what's now categorized as your very high wildfire risk zone. So I was wondering if you could speak to that a little bit, if there would be maybe motivation to expand the HFTD tier 3 to include that very high wildfire risk zone, or kind of what is the justification going on there for then using these risk maps and how they're applied to then decide where you're doing the bulk of your mitigations?
Hi, this is Cindy again. Okay, so the first priority is always going to be, your tier 3 high fire threat districts. And so that's going to be, priority 1. We're going to focus all of our work, all of our, grid hardening efforts, pole replacements, fuse replacements. That's going to be like your go-to first region of attack. The second is, dealing with, the rest of the service territory, which is a majority tier 2. So that South Lake Tahoe region that is, very high wildfire risk, so it's, just west of the HFTD 3 and, west and south. That region is, the next priority. So it's HFTD tier 3, and then it's tier 2, and then that reacts, very high wildfire risk area is our next level for prioritizing all work.
And so that alignment between basically, so you're going tier 3, tier 2, and then the reacts risk model, is that because there's maybe low probability of ignition or something that is different from the way that the risk is evaluated in the CPUC determined tier 3 and tier 2 that puts that down at a third ranked priority?
I can speak to that, having been involved with the CPUC high fire threat district mapping process. One of the components that went into that, actually the main component, was impacts to people and improved property. That's what was used as the tier definition for the tier 3 areas and the tier 2 areas that are now the HFTD map. There was a 10-year look at climatology that was done as part of that, but the ignition model that was used in the HFTD map wasn't informed by outage data or by ignition data. It was an estimate that the ignition probability increased with the square wind speed. After having looked at wind patterns and correlating outage data against wind, it now looks like that dependence is probably underestimated slightly. So what that means is that some of the windier areas in Liberty's service territory that might have a higher probability of ignition, but less of a consequence due to impacts on structures are now showing up as higher risk due to a slightly higher probability even though that consequence piece is a little bit lower than some of the other areas. So I think that's part of the reason for the for the updates to the recent zoning.
Thank you for filling that in.
Yeah, does that answer your question, Sari?
It does, yes, thank you.
Turn it back over to Holly. Do you have more questions?
Yes, I've got one more. So I think it's obvious that each of the utilities have unique service territories and unique risks. But one thing I noticed in the presentations is that the risk modeling methods used between the three utilities had some pretty significant variation. We have PacifiCorp using Technosilva, Liberty and Bear Valley are both working with Reacts for their risk mapping, and Bear Valley is working with Technosilva for real-time data. And we have OEIS is hosting the risk modeling working group. One of the purposes of that is to try and develop some best practices and alignment between utility risk modeling. So I'm curious if any of the small utilities have worked together or identified some best practices or standards or technologies used by other utilities, either other small or other large utilities, that they are planning to incorporate to kind of create that alignment.
Yeah, so this is Steve, and we take part in those workshops, and then I have meetings with my counterparts at the IOUs in California to discuss, the evolution of their modeling efforts and any lessons learned. And we're just looking to adopt what has already, what the other utilities are already doing and learning from what they have done. And so we definitely are reaching out. We're asking questions. We participate in the workshops. So I'll leave it at that.
Yeah, I think we participate in the workshops. So that's certainly a source of exchange. I think we've looked at what other utilities were doing as we proceeded. We certainly weren't the first to utilize React's expertise. And we definitely weren't the first to then seek out some of what Technosilva had to offer. So I think we've been trying to watch and learn, see what the other utilities are doing and seeing how it worked out for them.
All right, someone from Liberty want to respond?
I'm sorry, what was the question again?
So the question is, so we're, it's essentially about the variations in the modeling strategies between all the three smaller utilities. And we're starting to see some more alignment in risk modeling for the large utilities, but based on the presentations today, it appears that there are still some pretty significant differences in how the small utilities are modeling. And so the question was, have you identified any best practices or technologies or standards that are being used by the other IOUs that you're planning to incorporate in your risk modeling? And then to what extent have you learned or participated in the risk modeling working group?
Oh, got it. Okay, so we are, in the process of, just evaluating all the results from the wildfire risk modeling, looking at the, the risk mapping. So we're really in those, kind of initial stages of risk assessment. And so, to the extent, we can gain some, data analytical tools, related to risk modeling that other IOUs are using. We will explore those probably this year. So hopefully that helps, Holly.
Okay, thank you.
Great. And then Zoe, did you have any more questions?
Maybe just I'll do a broad kind of follow up on what Holly just asked. So, and kind of what's been tossed around for 2023 WMP guidelines is this idea of possibly freezing the risk modeling. And so it would be great to hear from the SMJUs on how that would impact their progress, since it does seem like they're very much in the kind of steep part of the learning curve and rapid development for their risk modeling methodologies. So if they could comment on that, that would be great.
Yeah, I'm not quite sure how to respond. So you're asking if pausing the risk modeling?
Yeah, so
I don't think I understood the question.
Yeah, so there was a proposal for the 2023 WMP guidelines to freeze the risk modeling, and that's as much information as we also have on the intervener and the stakeholder side, which I believe or interpret, and I don't know, maybe Andy knows more, to kind of mean using the risk models that are currently in place for forward 3-year planning versus massive overhauls in risk modeling on a year-over-year basis. And so I'm just wondering, from the SMJUs that are really doing a lot of model development in this phase of the WMP development and through 3-year cycles, are there plans to make major overhauls in the risk modeling that are anticipated to improve risk-based or risk-informed mitigation planning? And how might that freezing impact you?
And Steve, I might be able to take this one because I think it's almost like a different answer depending on which application of the model, or not to say we have tons and tons of models, but we have kind of the long-term planning model, and then we have the operationalizing of that and kind of the decision-making, the dynamic model. I can certainly appreciate, a proposal to freeze a long-term risk model that informs long-term projects, because we do struggle with that from time to time, where I have a model that says, oh, this is my high-risk circuit. It's kind of that ignition risk piece. It's a little bit more of a stable risk assessment. It doesn't change day to day. And so I start my work on my 14-month project. And then if I were to refresh that 6 months later and somehow it said, oh, no, work on this other circuit, well, do I take all of those resources on my 14-month project and shovel them over to this other circuit? And you could envision a scenario where you're just kind of chasing your tail. And so I do think we'd be open to kind of freezing our view of long-term risk as we work through the 3-year WMP to work on the projects. What's a little bit different, though, is, we wouldn't want to stop advancements in risk modeling. I would hate to turn to Steve and the meteorology team and say, don't get any better at dynamic risk assessment and decision-making, because that doesn't sound quite as much of a good idea, because that is a much more dynamic field. But as far as changing, maybe freezing the requirements or freezing a schema, freezing your view on long-term risk, I could see tons of benefit around that, because it allows us to work our plan, just maybe not so much in the dynamic space, if that makes sense.
Yeah, from Bear Valley's perspective, I'd like to add that I agree. When you're looking at asset deployment and prioritization that may make sense. But, you know, when you're applying these models to PSPS, the decision-making, that's a much more dynamic situation. And we want these, and we know these models have shortcomings right now. We just spent time talking about the ignition database. And so as we make improvements in fire propagation and how to predict ignitions, I think those do have to, you know, we don't want to freeze them for 3 years necessarily.
Liberty?
I'm sorry, this is Cindy from Liberty. We agree with Pacific Core on this one.
And so maybe kind of a quick follow-up question to that is how far forward are you planning, say, like grid hardening work based on a model that was, I don't know, maybe a version was called complete at the beginning of 2022. So is that model being used to plan projects through the entire next 3-year WMP cycle, or are you using annual model update versions to then plan long-term forward-looking grid hardening or other mitigation work, I guess maybe on more of an annual or year ahead basis?
Yes, Steve, I can answer this one because I think it's probably more in my camp. As far as how forward looking, it's around 2 to 3 years. So it's so generally we're working on a sequence right now. We're working on our grid hardening based on a model and what it told us about a year or year and a half ago. And it really just depends on the project pipeline time. So with our line rebuilds, they tend to take at least a year, if not more, depending on permitting and construction constraints. So you tend to have to know what to work on years before you get there at times. And so it does tend to be that 2 to 3 year outlook that's a little bit consistent with the WMP cycle.
Great, thank you.
For us, I would just add that there are certain projects like covered wire. We know we're going to be doing covered wire for probably the next 10 years. Okay, a certain amount per year. It's now adjusting the prioritization and trying to look out 1 to 2 years and using the models to try and figure out where we want to prioritize it so that we get a better risk reduction sooner. You know, that's where the models come in, but I think it's pretty odd. We can pretty much figure out that we're going to be doing this for a while, some of it.
And for Liberty, we do a 5-year forecast. So it's part of our long-term capital budgeting, where we, look at all of the planned projects that were in scope. Let's just say, covered conductor, those are, you need, years in advance to plan and design those types of projects. So we do have, the 5-year outlook, and then we also review annually all the projects for the next year. So we have like a capital budget refresh that's done every year.
Thanks, everyone. That was really helpful, just kind of understanding the duration of the planning and then kind of how long these risk models are used for until there's a new new input, new version.
Yeah, I agree. Thank you so much. And go ahead, Adrian.
I was going to say, I think we're about 25 minutes into the lunch hour, so we should probably take a lunch break now and come back at 1:25.
Great. Sounds good. Yeah, thank you so much to all of our presenters and panelists and questions from attendees.
James, can you maybe update the slide, the lunch break slide? Yeah, thank you. Hey, James, are you there?
What's going on, Adrian?
Here, let me finish plugging in my headset here. So Colin is up next, but Colin is logged in, I think, as an attendee and not a panelist. So
Mr.
Colin
Lang, right?
Yeah, Colin Lang.
Promote him right now.
Cool.
Yeah, I'm trying to promote Colin, and he might have an old Zoom client, and it's not letting me promote him.
Okay.
So he should be able to unmute himself and stuff, but yeah, it's not letting me promote him, and that usually is indicative of somebody using an old Zoom client or connecting from a platform that doesn't allow for that extended control.
Yeah. Well, I think maybe I Teams chatted him to log out and use the link that he should have received from you to log back in, but
I can verify that he should have got, if he gave me his name, I gave him a panelist link, but let me verify that he was in there.
yeah, maybe he wasn't.
Yeah, he's there. I'll resend it so he has
Okay.
it at the top of his.
Sounds good. Thanks.
Yep.
Hi. Were you just speaking?
Yeah,
Trying to
I was just I was just talking about you.
Yeah. Does this work as me as a panelist, or should I log back in with the proper link?
I tried to promote you to panelist, Colin, and it wasn't letting me promote you. So I'm resending you your panelist link. So I'd suggest you just connect with that and
Okay.
call it good.
Okay, I'll be right back.
All right.
There we go.
Yep. Okay, Colin, if you're ready, and if James bring up the first vegetation management slide, maybe for the first presentation, we should go ahead and get started.
Thanks, Adrian. Good afternoon, everybody. My name is Colin Lang. I'm an environmental scientist with Energy Safety. We're going to move to the vegetation management portion of today's workshop. Vegetation management can reduce both wildfire ignition and consequence. It involves planning for both the canopies surrounding overhead lines and the understory in and around the right-of-way. In the past few years, utilities have increased the scale and scope of their vegetation management programs to address contact with vegetation, which is a significant driver of wildfire risk. As per this morning's, we'll have the same format as this morning. We'll hear from, I believe, PacifiCorp first, yes, and then Liberty and Bear Valley, and then afterwards we will have a Q&A session with some of our stakeholders. So if we could have Brian King, you're all set, Brian.
All right, good afternoon. Sorry, I see one moment. Let me pause just briefly here and I'll close some blinds behind me to get a little more better view of me. Apologize. All right, good afternoon. My name is Brian King, Director of Environmental and Vegetation Management with Pacific Power. Appreciate the opportunity to speak today and provide an overview of some of the achievements and opportunities with respect to PacifiCorp's vegetation management program. Next slide, please. So in 2021, PacifiCorp implemented its Wildfire Mitigation Plan and conducted its vegetation management program. This work included our routine maintenance or our detailed inspections and correction work along our distribution and transmission lines. Also included our patrol inspections, the incremental inspections we conduct, and correction work along our distribution and transmission lines, pole clearing activities, as well as our post audits of tree work completed. In 2022, this year, PacifiCorp, we will continue to implement our vegetation management program and identify opportunities for improvement. Some of these opportunities for continuous improvement include the continued refinement to our data collection capabilities through updating our mobile data management software, implementing an overhang reduction pilot project, increasing opportunities for customers to provide feedback by reinstituting a customer satisfaction survey, and enhancing our QA/QC capabilities through increasing staff resources dedicated to conducting post-work audits, reviews, and so forth, which will help drive continuous improvement of the program and inform future decisions. In the next couple of slides, I'll further highlight some of these program improvements and opportunities. Next slide, please. So in 2020, PacifiCorp transitioned from a largely paper-based system of record to an electronic one, using a mobile software tool. So this mobile data management tool basically consolidated all of our paper maps, handwritten records, and disconnected spreadsheets, Word documents of the past into a queryable database with report generating functions and capabilities. There are various forms that the users of this tool access to collect information, such as an inventory form, a work complete form, adder form, adding more work, audit exceptions, and so on, that are spatially referenced or tied to a specific location by the latitude and longitude. Users of this tool in the field using a tablet enter information into the system by dropping a point or a pin, as you can see in the graphic there, some pins or green dots, other icons, and filling out forms that are tied to that point. As additional work is conducted at that location, additional forms tied to the same location, work location, are filled out to record the work, and the icon associated with that location or point may be changed to visually depict work at that location has been completed, or if there are any issues that need to be addressed at that location. So this tool has resulted in process improvements, including how work is planned and assigned to crews, how progress is tracked and work is documented, and how information is recorded and communicated to crews conducting the work at a work location, such as any customer concerns or special considerations that need to be addressed at that work location. It's not a perfect system. However, we are continually making improvements along the way through coordinating with our foresters and our vendor to identify and develop new forms or modify existing forms to further enhance our data collection capabilities, work tracking, and reporting capabilities. A recent example of an improvement implemented this year in 2022 is with respect to hazard trees and species information. So we have improved our inventory form, the form used by our pre-listers or inspectors, to include the ability to quantify hazard trees and collect species information. Previously, hazard tree removals were lumped in with other removal efforts and could not be teased out. With this improvement, as we collect more data through the years, it'll allow us to see trends in specific areas and provide a new data point to inform future program-related decisions. And from utilizing this and transitioning to the mobile software tool over the past couple of years and our efforts to continually refine its use, one of the most significant benefits that we've realized and have seen through the use of this software and this tool is the information is real time, which allows us for an increased ability to identify issues and address them to continue to move the program forward. Next slide. In 2022, this year, we'll start our enhanced overhang reduction pilot project. The purpose of this activity is to reduce the amount of vegetation or limbs overhanging power lines and further decrease the potential of wildfire ignitions due to vegetation and conductor contact, and to also, through this pilot, determine the efficacy of enhanced pruning, such as ground to sky or similar pruning, due to the increased amount of crown or vegetation removed from a tree to achieve the increased overhang clearance. We plan to evaluate the subject trees within 1 year of work to visually assess the tree health. We want to be thoughtful on implementing this activity to account for how tree species may respond so that we may minimize potential for an otherwise healthy tree to now start to decline as a result of this activity. So we may also conduct additional monitoring as needed in subsequent years and based on results to consider alternatives. So this year we'll be identifying candidate segments of distribution lines where we will plan to implement the enhanced overhang reduction in 2023. And then in 2024, visually conduct that visual assessment of tree health and to see how the trees are responding to this more aggressive pruning. And then further inform our program decision on implementing this and where it makes most sense to implement this type of activity moving forward. Next slide. Conducting vegetation management activities within various jurisdictions can pose challenges, as we all know. We've seen delays. Pacific Corps has experienced delays in conducting vegetation management due to land managing agency concerns or needed environmental evaluations and so forth. With these challenges come opportunities for collaboration as well to achieve mutually beneficial outcomes. So with federal and land managing agencies, specifically the Forest Service, we are continuing our efforts to develop operations and maintenance plans to streamline process We anticipate the first plan to be finalized with the Klamath National Forest this year, and we're already implementing processes identified in the plan, which has already benefited not only vegetation management work being approved to move forward, but also other maintenance actions as well. And we're engaging with other forests in Northern California within our service territory footprint this year to initiate that process as well. And through the outreach and education that is inherently part of the development of these plans, we anticipate additional opportunities for collaboration to be realized with these agency partners. And in that vein, over the past several years, we have also collaborated with local, state, and federal agencies, as well as private land or logging companies on fuels reduction and safety projects. We've partnered with CAL FIRE to clear vegetation from roads to allow for emergency vehicle access and other fuel reduction projects along our power line rights of way. We've recently partnered with the Forest Service to remove several large trees on the edge of a transmission line corridor to augment a fuels reduction and public safety project along Highway 89 corridor. We also have worked with the Dunsmuir Fire Safe Council to minimize potential spread of wildfire if ignited from the I-5 corridor from another fuels reduction project. And we continue to collaborate with logging companies as they work near our facilities to augment their work and ensure trees are safely removed along our power line facilities. So we look forward, PacifiCorp looks forward to identifying other opportunities for continued collaboration with our agency partners, communities, to also improve our workflow process through continued improvements with our mobile data management software, and implementing and learning from our overhang reduction pilot as we strive for continuous improvement within our department, our program, the vegetation management program, to further minimize the wildfire ignition risk and increase our reliability in the service we provide to our customers. So with that, that is the conclusion of a brief highlight and overview of some of the vegetation management activities that we're undertaking, have undertook last year, and are looking forward to implementing this year in 2022.
Great, thanks so much, Brian. And we'll move to Liberty with Peter Stoltman.
Peter, you're currently muted. And we still cannot hear you, Peter.
Can you hear me now?
There we go. Thank you.
All right. It had to announce to me that I was unmuted, but thank you for that. My name's Peter Stoltman. I'm the manager of vegetation management for Liberty. And if you want to go ahead and proceed to the next slide, I will talk really, instead of any specifics, I'm going to provide overview of where Liberty has come from when we first filed our Wildfire Mitigation Plan at the end of 2019 and beginning of 2020, and to where we've come from there in the last 2 years. So, just looking at the overall strategy of the program, we've really made a wholesale change in how we're managing vegetation on the system. Initially, we were, using a cycle-based approach, which is a very, typical standard way of managing vegetation throughout the industry, and using growth studies from consultants and assessments of the system to determine, what the right cycle would be, and using that to manage all the potential threats that vegetation may pose along the system. So a single inspection would be looking for clearance issues, fallen risk from healthy trees within and outside of the right of way, or any obvious defects from, dead or dying trees. Those would be looked at the same time. So, an inspector would be looking at pretty much everything, any tree that could potentially pose a threat to the system had to be considered as very comprehensive, but also very difficult and in some cases time consuming as well. So we've since then, started kind of breaking that up into three main categories where we look at the clearances, the patrol inspections for obvious dead, dying tree threats that are posed on the system, and then doing the detailed inspections to inspect for hazard trees, and basically kind of check everything along the way. And so this is, this approach is kind of designed to really have a multifaceted, layered effect so that when one inspection is being performed, then we're also having those inspectors just double check any other conditions that are out there. So if there's a lot of dead trees, that they're checking for, clearances. It's not that they're not going to correct those conditions, but in a way it provides assurances and is what's known as a defense in-depth strategy, which is really borrowed from the NERC FAC transmission vegetation management compliance strategy for bulk electric systems, and we've kind of taken that approach and applied it to the distribution system here at Liberty. So with that in mind, we're also implementing quality assurance, quality control of those inspections of the work that's being done, so that, again, that just provides another layer of protection to make sure that the work that we're doing is being performed to the specifications and to achieve the objectives of the program. But more so than that, we're getting a lot of really good data from those audits, and now we're starting to use that to inform the program and where do we have gaps, where do we need to make changes, where do we need to potentially increase training of the inspectors, or where there may be something in our process or our documentation that isn't clear enough for somebody to make a decision without having to kind of really start guessing. So it's been helpful. We're just kind of starting to transition from just collecting data into really putting it into action. And then with all the work that we're doing, I think there's the initial concern of, do no harm, right? So that the work that we're doing doesn't negatively impact the environment or the community. But at Liberty, we really believe that, a well-run vegetation management program that's following best practices was a benefit to the community. So we're looking at the work that we're doing, not just maintaining compliance and not causing negative impacts, but how can we ensure that the work that we're doing is providing a net benefit to those areas in which we're working. The next slide just gives a overview of the volume of work that's been undertaken by Liberty. So the first plan at the end of 2019, you can see that we were pruning and removing 11,000 trees, which was a huge jump from the previous year. And since that time, we've continued to increase up to another 30% increase in work volume since initially filing the WMP, as well as decreasing the time between conducting an inspection and actually performing the work. So, when looking at that same time frame where we were averaging a year between performing a detailed inspection, getting that work done, we've gone from a year to, on average now, a 9-month duration between inspections and work completion. So that's something that we're really happy with, to be able to achieve both of those things at the same time, which is definitely not without its challenges. And so the third number there is the labor increase. So when we filed the plan in 2019, Liberty had 4 internal vegetation management staff, and we added 1 last year, and we are adding 3 positions this year. So in that same time frame, we're going to double our internal labor force, contract resources, up to get that work done, but to administer the work, to track the work, we recognize there's only so much that we could do with the people that we had. And so Liberty's been really good at investing in the program to not only just get more work done, but to make sure that we're maintaining quality or improving quality at the same time and getting the right resources in place to be successful. The last slide is really, if you look at just, again, high level, where we're, trying to take the program. So, using a more data-driven approach, taking advantage of technology that's available to us and what we can do to gain efficiencies in the program. The biggest improvement probably that we could point to is the use of LiDAR for maintaining and inspecting for clearances along the system. So, we initially 2020, we surveyed half of the system with LiDAR to check vegetation to conductor clearances. Last year, we did 100% of our overhead system. And for the time being, that's the plan moving forward, is to do an annual overhead inspection using LiDAR technology to check for vegetation clearances. At the same time, there's additional data that we're collecting as far as like high resolution ortho imagery and looking into additional use cases of that to determine tree health of the vegetation outside of the right of way, or the number of trees that are capable of impacting our lines. So, last year I couldn't tell you how many trees we even have in our inventory, and now I know to a very high level degree of accuracy that for our approximately 700 miles of overhead line, we have 700,000 trees within our inventory, and of that 700,000 trees, there's approximately 230,000 of them that are capable of falling into and striking the facilities, just based on the geography, the height of the tree, and the distance from the wires. So makes things easier to know what you're dealing with and easier to manage when you have, that much more insight into what you're trying to manage. So we're really looking at how to again, take the data, use of emerging technology to better inform the program, to take some of that guesswork out of the work, because there is definitely skill sets that are developed over time that the better we can use the technology to help improve our sharpness when we're making these decisions, we're looking to do that to the extent possible. And then beyond that, as I mentioned on the first slide, maintaining compliance and not having a negative impact is the floor for us as far as I see it. And really from there, we're looking at how can we demonstrate, looking into other factors of the program to continue to provide benefit to the community, to the company, to every the people that work for us, and really focusing on the positive impact we can do with this work, as opposed to just not having bad impact. I think, like I said, that's the starting point, and then from there's a lot of good that we can do. So with that, as all I have, and happy to take questions when the time comes.
Great, thanks so much, Peter. And last but not least, we have Jared Henneman from Bear Valley.
Good afternoon. Can you hear me all right?
All good, Jared.
Sounds good. Sweet. So I am the wildfire mitigation reliability engineer here at Bear Valley Electric. And I kind of manage the vegetation management folk here. Next slide, please. So some of the accomplishments in 2021, we continued the trend of zero tree related ignitions, trimmed over 7,800 trees, removed over 157 at-risk trees. And compared to other utilities, these don't sound like a lot, but we are such a small utility that this was a pretty big accomplishment, only having a handful of tree trimming crews. 2021, we completed our LiDAR survey on our whole service territory, along with the UAV inspection. And once we received all the LiDAR and UAV data, we bring on extra crews just to address these issues that any of the LiDAR or UAV inspections found. And since 2020, we have removed over 300 trees in the service territory and trimmed over 14,800 trees. Now, one way we see that we're, to have an effective enhanced vegetation management program is we have created a vegetation density percentage, and we used it from the LiDAR data. And since 2020, from 2020 to 2021, we reduced the vegetation density around the power lines by almost 5%, which is pretty good. Next slide, please. So 2022 goals. We are planning on bringing on a pre-inspector here in the next month or two to help planning with the crews to hopefully shorten our cycle. And then we're going to be planning on shooting for at least 72 circuit miles of EVM work and hopefully removing at least 88 trees with strike potential. We're going to continue our UAV and LiDAR inspections, and we want to do at least 72 veg management QCs. I'm also in the middle of planning a tree planting program to help give back to the community for the trees we're removing or trimming. And a big part that we're excited for is we're implementing a brand new tree inventory system. If you go to the next slide, please. So this system is a lot like what Brian from Pacificor went over. It's going to be a GIS database for, and it'll create a unique ID for each tree. And it will hold a lot of data for each tree, species, height, condition, pretty much everything we're going to need moving forward. Our program right now holds very basic information for each tree. So having this data, we'll be able to start collecting what we need for trends, data requests, stuff of that nature. And like Brian was saying, it's real time. So if somebody sees a vegetation issue, they can put it in, take a picture, and it'll be in the system for our tree crews to address without having to go through paper or any other phone calls or anything like that. And then again, it's going to be extremely accurate location. We are such a small utility here, so we're trying to bring everything up to what other utilities are doing. So doing a lot of work here. So, and next slide. And that's the presentation.
Great, thanks, Jared. We will launch if all the panelists can come back. And I will invite, I believe it's Zoe back from GPI and Matthew Carl from Cal Advocates.
Sorry, do you want me to start, Colin?
Yes, sorry. You beat me to the punch.
Thank you. Great, thank you for these summaries. So my first question is kind of specific to Pacificor, and then maybe broadly the other two SMJUs can answer. The pilot program for the line to sky clearance, basically removing overhang branches. I was wondering if there is existing data on how that both reduces risk and also impacts tree health from the IOUs that are already implementing those line to sky clearances?
No, that's a great question. And in the little bit of research that I've done and in conversation with some of our foresters within our department, there's not a lot of existing information. And we do coordinate with, for example, PG&E and hold some regular conversations with them. And this has been a topic of conversation to see how it's been going from them. So we're taking their feedback, lessons learned into consideration. And that's why we're proposing this measured approach to kind of build into it and really see how the trees respond to this more aggressive pruning, because we don't want to cause ourselves more unforeseen issues with tree health declining, and then now we have a hazard tree that once was a healthy tree and so forth. So we do collaborate with other IOUs on that, and we'll continue to do so to learn from their lessons as we implement this pilot project.
Great, thanks, Brian. And so I imagine then, and it seems like there isn't an answer yet, but there's a balance between potential tree health and then the risk reduction from actually removing that vegetation from above the lines. So I assume then there's also this component where you're measuring before and after risk or probability of ignition risk associated with doing that line to sky clearance as well.
Yeah, we do need to look into that aspect, right? It's the cost benefit, right? We need to ensure that whatever actions we do take will result in the perceived benefit, and looking at outage concerns, the mechanism of the outage, right? Is it a branch falling or is it a tree falling? And really tease that out so that we can better make a more informed decision on how to proceed and implement an enhanced overhang reduction program. Is it targeted at just a specific species, for example, or not? So.
Perfect, thanks. And then for Liberty and Bear Valley, have you guys implemented any line to sky clearing or considering it? What's the status on that?
At Bear Valley, we do blue sky or line to sky clearing for our 34 kV, which is our higher voltage line. And we don't do it on the 4 kV, which is the lower voltage line. But so far, I think it's only been about 1.5 years since we've been doing that. So we don't have, data back, or we haven't seen any trends of what kind of trees are affected in certain ways as of yet.
Yeah, for Liberty, we pull overhang from what we consider our transmission system. So that's the 60 kV and the 120 kV line. So we are, not keeping any overhanging branches within 1 foot. So that's one thing that we were able to have better insight into using the LiDAR data, where, one of the metrics that we're having delivered to us is, show us every branch, above those lines within 1 foot of those lines. And the reason being is, that if you look at, outage data, largely it's, fallen branches or trees falling into the lines. That's typically going to be the events that are experienced, the growing. If we're maintaining clearances, hopefully then that's not as much of a concern. We also have really heavy snow load here in Tahoe when we have a good winter, and so with that in consideration, it's better to go ahead and just get the clearance that we need to while we're there. With regard to tree health, we follow standard arboriculture practices, and so we can determine from how much of a tree that we need to take. At what point is it better to just remove the tree and and not try to keep it if you have to take that much, it's probably too close to the lines to begin with, to be honest with you, especially when you're looking at transmission voltages. So, you know, we'll do what we need to maintain the facilities, and then if at a certain point it's kind of like the wires of the tree, that's the decision you have to make. You know, then we have to remove the tree, because, you know, if we're going to take a certain extent. The one exception would be, you know, sometimes in the forest where we can't pull the wood out, right? Because we don't want to add a bunch of surface fuels. You know, we're looking at instances where maybe we'll top the tree. Maybe it's already dead. You know, maybe it won't die, but we're not just leaving additional fuel that we can't pull out of the forest at that point.
Great, thank you, everyone.
Thanks, Zoe. Matthew, let's go to you.
Thank you, Colin. Since I neglected to introduce myself this morning, I'm Matthew Carley, supervisor with Cal Advocates Safety Policy team. So first question, to what extent are you scheduling your VM inspections to happen prior to fire season annually? And what's your approach to identifying and correcting issues that are identified in those pre-season inspections?
So I'll go first. This is Brian King, Pacific Corps. So our routine vegetation management work is scheduled throughout the course of the calendar year. However, we'll prioritize the circuits that are scheduled to be worked as part of our routine maintenance that are in tier 2, tier 3 to be conducted earlier in the year, considering environmental factors. Some areas are snow, we can't get access to it yet, so it may require them to be worked a little bit later in the year. So that's our routine vegetation management program, or in the Wildfire Mitigation Plan, our detailed inspections. In addition to that, we have our patrol inspections that we implement to on our feeders, our distribution circuits, transmission lines, and those patrols are targeted to be conducted prior to the onset of the height of the fire season. And those patrols are primarily looking for, you know, fall-in risk, hatched trees, dead, dying, diseased trees, and potential clearance issues within 4 feet of the conductor. And so those patrols, as well as correction work, are targeted to be completed prior to the onset or height of the fire season.
So for Bear Valley, most of our inspection programs begin in the early spring. So we are finishing up all of our inspection programs now and should be getting the data back here shortly. And then we bring on additional tree crews to address these issues before fire season hits. Last year, we got all of the violations from LIDAR within the 4 feet before the heart of fire season really hit. And then same with patrols and our third-party ground patrol, we do all in the early spring so that we can find them before fire season hits.
At Liberty, we have the routine or detailed inspections and the patrol inspections happening year-round, and then we're, you know, kind of going back to the presentation where we're trying to decrease the time between those inspections, but it's just kind of a continual process of inspecting and issuing work and getting it completed. With the LIDAR inspections, the kind of rhythm we're falling into is having the acquisition or the flight occurring in the summertime. So we're getting that data delivered to us in the fall, winter, typically analyzing it over that time period in the wintertime, and then really focusing efforts on getting all of those clearance issues mitigated in the first half of the year. So, you know, we had this year a little over 6,000 locations to you know, work, and the goal is to have that completed by the end of June, and then the next LiDAR flight is scheduled for July. So we'll kind of have that 6-month cadence between an inspection and mitigation of those hazards. With regard to the pole clearing work, it's something that it's been kind of, starting, now and working to get it done before the fire season. And, that's kind of a moving target. We do the best we can. Last year, I think I'd say our fire season started in June. So we didn't hit that target, but, that's the goal, is to get all that done as soon as we can once the snow clears and we have access to all those locations.
Thanks, Peter.
Thank you.
Thanks, Matthew, for that question. Do you have any follow-ups, Matthew, at the moment, or should we ping back to Zoe?
No, we can go back to Zoe. Thanks.
So my next question, I think I'll start with Liberty. So Liberty provided a really fabulous table in their WMP, which shows basically the amount of vegetation management residues or biomass that was removed, and then the format that biomass was in, and then the place where it went after the vegetation management was done. So I had a couple specific clarifying questions for this for Liberty. One is, did that table capture all of your vegetation management biomass, or was it from one specific program, say like trimming or tree removal? And then the second specific question is the end use that's listed when the say end point of that biomass was landfills. Does that just mean that's the form that it was at when it was disposed of?
Yeah, no, that I am unmuted. Yeah, so that's a good question. So to answer the first part, that table represents one specific program in which we are focusing on decreasing fuel load on the system. So the routine vegetation management work from pruning, maintenance, basically the ongoing work that we've always done. A lot of that goes to transfer stations where, that's either being turned into compost and, repurposed at those facilities. And then the table that you're referring to is specific to that fuel management initiative. And those, we're taking it to locations. So one's a composting facility, and they turn the wood into compost, and a lot of times it ends up going back into the environment for restoration projects or soil erosion, projects for, stormwater prevention plans, things like that. There's a fair amount that has been over the last few years stockpiled at cogen facilities, but, there's a lot of interest in using that biomass, to generate power, but there's not really nothing up and running. But there are some places near us that are anticipating being up and running, and so they've been stockpiling it. But yeah, typically it's being used in some sort of either composting, stockpiling for future use as biofuel for a cogen facility, or at if you take it to your local landfill where they have the big mulch compost pile, that type of a situation, and they're composting it and reusing it for whatever they may need for it.
Great, thank you. And then I think kind of as a segue for Pacificorp and Bear Valley, are there any kind of end use pathways other than landfill disposal that you're routing your vegetation management residues to?
Yeah, this is Pacificorp. So our slash management activities, generally a lot of it from what we have seen as we we chip the material so that we have the wood chips generated through our slash management activities are generally requested and provided to customers. In many cases, we're finding that, or in the vast majority of cases, our customers are requesting the chips. Farmers may request it. They may use it to, and repair some ruts in their roads to put it as a kind of a road base and whatnot. So it is, 9 times out of 10, a customer or a farmer is asking for it. In other cases, the chips may be provided to a local wood mill if they have the capacity to take it, nurseries, landscaping companies, things of that nature. So we're finding another end use of it rather than taking it to a landfill.
Then for Bear Valley, we don't currently have a program in place, but if the customer, wants the chips, of course, we'll give it to them or whoever asks for them, but we don't currently have a program that we do anything other than take them to the landfill.
Great, thank you, everyone.
Brian, I have a follow-up question on that. I'm just kind of curious. Does PacifiCorp is like the chip donation or drop, is that sort of part of PacifiCorp's processes, or is it sort of just kind of this ad hoc kind of default that, everyone in Northern California knows PacifiCorp will give you their chips, which is a great default, but I'm just kind of curious.
No, it's probably a mixture of both in reality, right? It's a commodity, if you will, that people want and have uses for. And plus internally we have, one of the pillars of the company, environmental respect. And so we are always looking for different ways to manage our quote unquote wastes, our waste streams, right? For landfill avoidance. And so this is one of those waste streams, if you will, where we will look proactively look for different end uses and have a landfill be of last resort. So it's part of our company process as well as word of mouth, out in the community.
Thanks, Brian. Okay, we will go back to Matthew.
Thank you. This is sort of for all 3 of the utilities. I've heard some differences of opinion on the utility of using LiDAR for VM and for examining clearances. I know PacifiCorp had indicated that they weren't going to move forward with that program. Can you elaborate a little bit on the reasoning and why you felt that wasn't the most useful? And could the other utilities speak to why they have decided to move forward?
So yeah, this is Brian. So we're continuing to evaluate, technologies and so forth, satellite imagery, and we did conduct some LiDAR studies, and we found a high number for this particular study with that particular vendor we utilize. Let's say we found a high number of false positives, and so it left us with, let's say, more work to do, right, in order to really find an adequate end use or use case for LiDAR at this time. But as we learn more and continue to mature and the technology continues to mature, it's always something that we will continue to take into consideration and look at.
For us at Bear Valley, it's kind of just another tool in the toolbox. But we also don't have a huge area. We had less than 150 possible infractions within 4 feet. So that's not going to be a huge amount of resources to make sure those are right or wrong, or it's just another tool that we're using to ensure enhanced vegetation management.
At Liberty, we found that LiDAR, our service territory lends itself well to the technology, due to the terrain, the geography that we deal with, as well as the, shortened season with the long winters that we experienced to be able to move towards something like an annual inspection of all the lines to maintain those clearances. In order to do that with the traditional boots on the ground approach, I don't know that we would even have enough people, like the resources to be able to do that, and to get to some of the locations are just really difficult to get to as far as the terrain goes and things like that. So, where, and it's all relative, right? That 700 miles is small in the grand scheme of things for a lot of investor-owned utilities, and even Pacificor, that maybe is small in California, but still it's a large utility where it's not always like a pilot study for them may be our whole system, right? So it's in some cases maybe easier to deploy at that level, but we've also found that it's the efficiencies gained. So it takes two days to do our whole system with LiDAR, whereas we're nowhere near that, obviously, with boots on the ground, and then actually cost less. Looking at the numbers between the last year of detailed inspections, and it's not a pair of apples to apples comparison. So I don't want to make it sound like it is, but just the efficiency that we gain, that we can get through the system and get it done quickly, and be confident that we don't have clearance issues. For us, it was the right decision to do that moving forward for us. And like I said, we have territory which is really difficult to patrol by foot, and using an airplane is a lot faster and a lot easier, and it's worth it. And additional use cases that we're looking at too with tree health. Again, we're looking, we have pine and fir species for the most part, which also lends itself well to that technology, where we don't have to worry so much about, stressed live oak in the summertime that may show signs of being stressed. Our trees aren't dealing with that same sort of condition. So I think we're lucky to be able to take advantage to the extent that we are of that technology. And then, like I said, just the efficiencies we're gaining, the false positives we haven't seen, but we're also going beyond, the minimum clearance requirements, so that we're actually going to, 6 feet. Anything within 6 feet is a work location that we're correcting. So I guess we're already adding to the volume in that regard as well. But that maybe first year or two will be more work. Trees grow slower here too, which is also helpful. So I think after a couple of years, we'll see that over time, whatever that number is, and maybe it stays at 5,000-6,000 a year, and we can manage that. I think it may stabilize and it may decrease once we kind of get everything back to those maintenance clearances.
Okay, thank you. No follow-ups from me.
I do have a follow-up for Brian. I know we've talked a lot about LiDAR recently, and I correct me if I'm wrong. I mean, you mentioned it, but Pacificor is going down this satellite imagery path and kind of that sort of remote sensing. And I wonder if you could just briefly speak to what insights you've gained from using satellite imagery and data that you can use in vegetation management.
Yeah, I guess I'll caveat this with all the technologies have limitations, right? And depending upon the use case and so forth. We're relatively early on in the process, so we don't have necessarily a identified definitive answer on how this will truly benefit us. We're utilizing it as ways to, let's say, in lieu of LiDAR, a way to hopefully be able to process data a little quicker I appreciate some of the comments, like Peter's comment with respect to scale, right? You know, we're like with LiDAR, we're looking at our entire service territory, not only California, but Oregon and Washington as well. And so that data processing and the volume of data, there's issues there. And with some of the satellite imagery, we're hopeful that we can have a quicker turnaround, a more cost-effective approach, identifying trees within and along our rights of way that are within strike distance. So using the satellite imagery and so forth to identify those strike trees or strike potential trees is one use case that we're investigating a little bit more. Colin, if that answers your question.
It sure does. Thank you, Brian. I want to make sure I do a time check. Adrian, how are we doing on time?
Sorry about that. Having a little trouble finding my mute button.
No worries.
I think we're doing fine on time. See this. Yeah, since we started about 20 minutes late, you've got 4 minutes more that you can use on this vegetation management at this point. So if anybody has any last questions, you know, you can go ahead and do that. Take care of them. Anyone?
Zoe or Matthew, do you have a brief last question you yearning to ask?
Zoe, go ahead.
I can ask a quick question. So for a lot of the vegetation work seems to be done by contractors. So kind of what proportion is done by contractors, and then what is your QA/QC approach for that contractor work?
I'll go first. So in our, well, I guess our service territory, yes, our tree, the actual pruning work is done by a contractor. Our inspection work is also done by a contractor. Throughout our service territory, for example, we have roughly around 90 to 100 tree crews that are actually pruning work. In California, it's more around 15 crews. Previous years, we've been up to 23 crews conducting the tree pruning work. We, within our service territory, within the veg department, we have 10 foresters, of which four of which actually help support our operations in California for our vegetation maintenance activities. And as with respect to QA/QC, as the tree work is being conducted, our foresters, we conduct the post-audit work internally in-house with our foresters, and we'll follow along as closely as possible with the tree work as it is being conducted to identify any issues that may arise. Any exceptions or audit findings then are relayed to, documented in our mobile data management software and relayed to the contractor to correct. And as I mentioned in the presentation, we're also looking to expand that QA/QC capabilities by hiring more full-time Pacific Power, PacifiCorp employees. That will be their job task, is to conduct post audits to help ensure the work is being done in accordance to regulations and our standard operating procedures.
Then for Bear Valley, where all of our tree crews are contracted out, and usually we run about only 4 tree crews, so not very many compared to other utilities. And then our QA/QC are all in-house employees. So every week, an employee get the QA/QC assignment of where the contractors were that week, and then they go out and we'll QA/QC it.
At Liberty, again, similarly to the others, all the tree work itself is done by contract tree crews, and the majority of all the inspections are also done by contractors. Typically, when it's an internal arborist doing inspection or work planning. Work would be a special project or for a capital construction upgrade that we're going ahead of the construction crews before they rebuild those systems. But even that's starting to go more towards the contractor, and then we have a lot of public land around us, so all of the work that goes to any state agency, so State Park, California Tahoe Conservancy, Forest Service, BLM, all of those projects get reviewed and audited by a Liberty employee before being submitted for approval by the agency. And then we also have permitting requirements through the PRPR, Tahoe Regional Planning Agency, for trees over a certain size class. And so internally we'll audit or review those trees as well before submitting them for a permit to be removed based on the size. So, where that alone provides a pretty good level of check on the inspection process. And previously we would have, the arborists would be out there checking the work, working with the crews, making sure that everything looks good. But it wasn't really well documented. We didn't have a specific formal process in place. And so we started in 2020 with kind of a big, just let's go do an audit at once of all the work that we did this year. And then halfway through last year, we were able to secure a contract with another contractor specifically just to perform quality control audits of the tree work, the tree inspections, and all the other contracted work that's happening out there. And then kind of the next phase would be to start doing more like a quality assurance type check, where we may send somebody out just to any, sample of the system, go to a span and look at everything out there and see if it's all in good shape, and, kind of provide that, next level of assurances on the program's efficacy. But we're not there yet, but that's where we're, heading.
Great. Thanks, everybody. Thank you to the utilities for their presentations and answers, and thank you to Matthew and Zoe for your great questions.
Yeah. So next up is Kevin Miller and the Public Safety Power Shutoffs PSPS panel.
Thanks, Adrian. Good afternoon, everyone. My name is Kevin Miller, and I'm an analyst with Energy Safety. And I'll be facilitating, as Adrian indicated, the Public Safety Power Shutoff panel presentation. And we'll follow the same format as prior presentations, but if anyone is just joining, we'll have a presentation by each of the three utilities, and then time for question and answers at the end. And I'll just give a little introduction. Well, PSPS, Public Safety Power Shutoffs, have been used to reduce immediate seasonal fire risk caused by utility equipment. We know its use comes at a high price to customers in terms of loss of power. We here at Energy Safety, we remain focused on how and whether utilities are improving on their ability to reduce the scale, scope, and frequency of PSPS use. And we continue to remind utilities that while PSPS is a short-term tactic, it's not intended to be considered a long-term mitigation strategy for reducing wildfires over time. Last year, we asked questions focusing on what utilities are doing to reduce scale, scope, and frequency of events, focusing on frequency, and how utilities are improving their accuracy to predict PSPS events. And we realize that small utilities, haven't implemented PSPS events as much as large utilities. However, we still want to know your plan for minimizing potential scale, scope, and frequency. And we can see the way that things are going in regard to climate change, drought, wildfire risks, that the risk of having to implement a PSPS may not hold out for you. So we want you to have that plan in place and hear what that is. And we have additional focus this year on marginalized communities, how those are being coordinated with, and customer communications and notifications. So we look forward to hearing your presentations, and we'll start with PacifiCorp with Alan Barrett.
Thanks, Kevin. Appreciate that. In the opening comments, my name is Alan Barrett. I am the Vice President of Operations for PacifiCorp. And so I'll highlight some of the activities around public safety power shutoffs, as you mentioned, and then obviously whatever I don't touch on, I can address in the Q&A if needed. Go ahead and next slide, please. So first, let me touch on some context of how frequently has PacifiCorp used a PSPS in California. And so since we've established these protocols in 2019, we've had 2 PSPS events. We've had one in 2020, and we had another one in 2021. And you see their details in the table down below there. Also listed in the table is PSPS watches. So just like in the opening comments there, where even though we might not have a large history of usage of these, I thought it would be also interesting to bring in, well, external watches are that step right before a PSPS event. So how often were we in that stage that might have led to a PSPS event? So still a small number, but we are still taking the planning steps and preparation to both make sure it doesn't become something that is used more and more. We want to use it appropriately and want to do the wildfire mitigation to limit its usage or even need, right? That is the goal. So there's just a little bit of context for how often we've had the need. So now let's touch on some other aspects. If we can go to the next slide, please. So new in the public safety power shutoff realm is the establishment of a public safety partner portal. And so this will go live for us here in the next couple of weeks in June, where we're going to do our first phase of the solution, which means we'll have this portal available to our public safety partners where they can log on and get access and basically download, if we're coming up to a PSPS event or into a watch, the files that are appropriate for them and what they need to know, whether that's GIS information, whether that's critical infrastructure information. Obviously, it's just our way to communicate and make sure we're sharing the latest relevant information. So we're in the final testing phases and getting that set up here in the next couple of weeks. We'll go live with that. We'll train our public safety partners on how to access it, how to request access, and how to download that data. And we view that as continued evolution, that as we go live with that and get feedback through the monthly meetings and from the different public safety partner agencies on what can we do better with that site. But we already have plans for a phase 2 with this portal, which will be much more GIS based and interactive for downloading this information and selecting what information you want, as opposed to just basically a file server. It'll be more interactive. And so that kicks off here in June as well. While we deliver phase 1, we'll kick off phase 2 and look to have that delivered towards the end of the year, ready for next year's fire season activity. So that's what we're doing on the public safety portal front, making good progress, and that's a step change from what we were doing in 2021. So we're excited to see that push forward. Next slide, please. All right, now let's talk about the 2 programs that we have for our vulnerable population and going into PSPSs. One is the generator rebate program, and the other is the portable battery program. Now, both of these were established last year. And so for the 2022 activity, we're looking to expand them. So for the generator rebate program, which is available for our customers in the HFTD, where as a qualifying customer, they get a $200 rebate on a qualifying generator. If they're an AFN customer, they get an additional rebate on top of that. For 2022, we want to expand the awareness of it. We want customers to know if this is available for them and to take advantage of it. So that's our focus on 2022, It'll be part of our communication outreach, our media campaign, letting people know that this is available. They can go to our website, they can see if they qualify, they can see what generators are available and just how to go about the process, all available on our website. The portable battery program, which also was launched in 2021, made a little different here, where instead of customers going to our website and applying for this program for our medical baseline customers in our California service territory, we contacted them and had a contractor walk them through what their kind of a questionnaire to establish what their needs were, what medical equipment they might be using, what size of battery do they need. Our contractor then would procure the battery, have it delivered to the customer, help the customer set it up. And so in 2021, we conducted that for all of our medical baseline customers in our HFTD. And you see on the right there, kind of the success of that program, which is, 11% were not interested in taking advantage of the program. We couldn't reach 11%, didn't return phone calls. And 78% though did take advantage of it and had those batteries delivered and are utilizing them. In 2022, this year, we're looking to expand that now, instead of just the HFTD, to our entire service territory for our medical baseline customers, and forecasting to have 55% of our medical baseline customers have received those batteries by the end of the year. So both those programs, we're looking to see them expand this year and help out with the vulnerable population as we look to the impacts of a public safety power shutoff. Next slide, please. All right, and lastly, I just want to touch on our continued outreach. So when we talk about something as impactful as public safety power shutoff, it's not just the utility making plans and trying to educate customers on the impacts of those, but actually working with these communities and understanding both their needs, how can we incorporate that into our plans and have a greater understanding, and just make sure that if we do have an event, it's very well coordinated. So it's continued use of the same plan elements, such as tabletop exercises, which we conducted in Siskiyou County on April 28th, where we go down and talk with our emergency services in the area, public safety partners, and discuss critical infrastructure, telecom. I mean, what are the needs of the community? What should we be thinking about? And then new this year, adding a functional exercise, which is planned here at the end of May, where we actually open up our ECC and go through the functions of establishing the ECC, making the notifications, have the call-in numbers, making sure we have the right contacts, and just kind of walking through it more than a tabletop exercise, but actually functionally trying out the notifications. So that'll be here at the end of May. We have the continued media campaigns that go from May through October, where we just do various ways of outreach to our customers, whether it's the bill inserts, social media, radio, other media, just trying to make sure customers understand what information is available to them, directing them maybe back to our website. Just want to make sure they have access to not only what we're doing and our plans are, but what they can do for their own property. Also, I want to touch on just the PSPS website and making that available in Spanish, so that our actual website can be translated, and there's a Spanish version of the website now available for our customers to understand, if not just in a PSPS event, but can get access to wildfire mitigation and preparedness information in Spanish now, as they try to prepare themselves. Also in 2022, we held a webinar a month ago for customers in our California service territory, where they were able to join us online, basically walk through our wildfire mitigation plan, explaining the different elements, obviously what we're doing and what to expect, the multi-year system hardening, and how that all helps limit the impact of PSPS, even though it hasn't been used frequently, but to ensure that that remains the same. So we conducted that as well. So with that, that's some of the highlights with the public safety power shutoff and what Pacific Corps has done and is evolving in 2022. And so I'll address any other questions when we get to the Q&A. So thank you.
Great, thank you, Alan. Now, next we'll turn to Liberty. We have Elliot Jones, Lee Kielbasa, and Kate Marone.
Thank you, Kevin. Good afternoon. My name's Elliot Jones, and I'll be covering the PSPS portion of the presentation. I'm also joined by Lee Kielbasa and Kate Marone, and they'll be joining us for the Q&A portion after the presentations. Let's go to the next slide, please. All right, so first off, I want to talk about Liberty's approach to PSPS, the factors that determine our PSPS conditions, how we monitor those, and how we determine where to de-energize if PSPS conditions are met. So the first few factors, wind speed, humidity, and temperature are pretty self-explanatory, but the other indices probably deserve a little bit more explanation. So energy release component, or ERC, is a measure of vegetation flammability, and it varies daily based on the moisture content of live and dead fuels. Typically we see ERC peak during the summer months, and then it drops off in the fall after rains return and temperatures begin to drop. And the ERC is forecasted from weather station observations as part of the National Fire Danger Rating System, or NFDRS. But we also calculate ERC from fuel sampling that's performed weekly in our service territory. So we're actually going out there and collecting samples to sort of compare those live results from the forecasted ERC conditions. Next one is Fosberg Fire Weather Index. It's another component that we monitor, and it helps to gauge the potential influence of weather on a wildfire based on model output of temperature, wind, and relative humidity. Burning Index is an estimate of the potential difficulty of fire containment as it relates to the flame length at the head of a fire. So the higher the number on the BI means it would take more effort to suppress a fire under those existing conditions. And actually last year we incorporated BI as a factor that we monitor for PSPS. So how do we monitor these conditions? We've developed a Liberty specific fire weather page, and that provides a 7-day forecast for each of our PSPS conditions. And that forecast looks at 6 different weather models like the Euro, NAM, and GFS. Those models are plotted on a graph, which you can see on the right side of the slide there. The graph also shows where our threshold for PSPS for that particular PSPS factor is. You can see that shown as the red dotted line there on the graph. And then additionally, we utilize our 29 weather stations that are used to observe wind speeds, temperature, and humidity in real time, so that we can compare those as well to forecasted conditions. And then, this PSPS forecast is provided for 46 different zones we call PSPS zones within our service territory, so that we can determine, at a more granular level where we should be de-energizing, which circuits would be potentially impacted, and so on. So that's kind of how we determine where the worst conditions are and where we might need to de-energize. Let's go to the next slide, please. All right, so now I'd like to talk about what we're doing as a company to prepare for PSPS events. But first, it's probably worth noting that Liberty has not had an official PSPS de-energization. With that being said, we've worked really hard to make sure we're prepared to execute on a PSPS, and to minimize the impacts to our customers and to comply with all of the requirements that need to be followed when in fact we do de-energize. So it was 3 years ago that we first developed a methodology and our thresholds for PSPS. Since then, we've put a whole lot of effort into training and preparedness around PSPS. Probably most importantly, we developed our operations and communications related procedures that we have sort of rolled into what we call our PSPS playbook. The playbook is used as a guide for any of our staff that's involved with PSPS events. It details the roles and responsibilities of our incident management team, and it provides guidance for each one of those roles throughout all stages of a PSPS event. It's been really helpful in our training and preparedness. In addition to all of these PSPS trainings and exercises, we work throughout the year to meet with public safety partners and critical infrastructure providers. And they're also included in our training exercises throughout the year. Last year, we worked to better identify our critical facilities within the territory, and we have developed a better way to map them through our GIS system. So we can quickly identify those critical facilities where a PSPS may impact them. And we're able to pull those out and generate our list of communications to those critical infrastructure providers. We're also working to update our PSPS portal for our public safety partners to provide more detail during events, to provide GIS information that can be pulled into their own systems, and just generally try to give our partners all the information they need to understand the scope and scale of a PSPS. Let's go to the next slide, please. All right, so PSPS and customer support. I think I'll start with talking about our customer notification process. So for our general customer notifications, we'll notify approximately 48 hours before power is shut off, and then again 24 hours before. And then just before power shut off, we'll also communicate again during the PSPS event, and then once power has been safely restored as well. Our main method of communication is through our Everbridge system, which provides text, phone call, and email notifications. We have Spanish support that's provided wherever possible. So in our PSPS toolkit materials, CRC flyers, multicultural media channels. And then we also have bilingual call center representatives to support anyone that may be calling in, and as well as our website during the event, during a PSPS event. We also use social media as a communications tool. Our community-based organizations and public safety partners are communicated with as early as possible, up to 72 hours in advance. AFN customers, they also receive communication as early as possible following our public safety partners. And then in the event medical baseline customers do not confirm a receipt of our communication attempts, which is first through text, phone, and email through the Everbridge system that I noted earlier, then we'll make personal phone calls to those folks. And those will come straight from our customer service representatives. And then even furthermore, if we still can't contact our AFN customers, we'll do door-to-door. We'll go knock on their door and try to get in touch with them directly. Community resource centers. So we've secured 9 CRC locations throughout our service territory. Each one of those CRCs is within 30 miles of our customer base. All of the CRCs have backup power. They're ADA compliant. The restrooms are either fixed in the facility or there's portable ADA compliant solution. We have pre-staged mobile quick space containers that are deployed, and they're stocked with assistance forms, water, snacks, chairs, tables, mobile phone chargers, power cords, and also Wi-Fi support for the general public to use. The CRCs are staffed from 8 a.m. to 10 p.m. daily until the power is restored. And then we plan to utilize our CRCs also as a way to reach our customers in terms of our available programs, AFN identification, and PSPS preparedness information. In one area of our territory, we actually use the community has expressed the need for this is in a ranching community where when the power goes down, their wells don't work and they can't water their cattle. So we provide water trucks in those circumstances to go help provide those ranchers with the resources to water their cattle. So our staffing support for our customers during PSPS events, as I mentioned earlier, we have bilingual call center representatives available. Our CRCs also have bilingual support staff there. And then we're also working with CERT teams in some of the areas of our territory to help support our CRCs and our PSPS efforts. We've also held town hall meetings, both pre-season to describe the events of a PSPS and try to provide a better understanding to our customers of what to expect during a PSPS. And then we'll also do that during an event to try to communicate as much information as possible to our customers. Some of the additional resources that we're utilizing this year, we're working to connect with 211 service throughout our service territory. It is available in most of the counties, except for a couple in our service territory. And so a web page has been now dedicated to sharing resource information with our customers, and it includes 211 specific websites for each county. Our CBOs, we have some newer positions now at Liberty, which include a business and community development manager and a bilingual community outreach coordinator. And they're really helping to expand and support our CBO networks. It's allowed us to increase communication lines for PSPS awareness and preparedness by sharing materials. They're making a lot of presentations, also available in Spanish, and participating in collaborative outreach opportunities. Liberty plans to include CBO contacts in the early stages of PSPS communication so that they can help support our planning for AFN customer communication. And then this year, we've also partnered with Meals on Wheels to secure shelf-stable food items that can be distributed to our customers in advance of the potential PSPS events. So yeah, over the last year, we've put a lot of effort into our better ability to support our customers, working on communications and also those resources that we're trying to make available in the event that a PSPS does happen. So with that, I think that concludes my piece of the presentation. We'll be ready for the Q&A after this is done. Thank you.
Thanks, Elliot. With that, we will turn to Bear Valley.
Very good. Thank you, Kevin.
Thanks, Sean.
All right. Welcome to the Bear Valley PSPS portion of today's workshop. My name is Sean Matlock. I'm the Energy Resource Manager for BVES. On the next slide, you'll see how we will be allocating our time this afternoon, basically focusing on bullet point 2 here, the decision-making criteria. On to the third slide. This provides an overview here of Bear Valley Electric's service territory. As you can see, it's relatively small. Bear Valley's elevation is at 6,500 feet. And I believe that because of that and decades of building to high and stringent criteria for ice and snow making or snow loading onto the poles, that Bear Valley has never had a PSPS event. On to the next slide. When it does come time to PSPS considerations, there's a number of criteria that upon which we make our decision. Criteria, this includes design limits, system conditions, fuel availability, and the likelihood of wildfire spread. This includes things relative to high wildfire threat, for example, relative humidity, temperature, and the current NFDRS ratings. There are other indicators that Bear Valley considers, such as red flag warnings. And in regards to the NFDRS, they are specific to San Bernardino County and not necessarily indicate present conditions at BVS. Therefore, that's why Bear Valley contracts a meteorologist and considers conditions at Bear Valley's weather stations as well. Bear Valley has developed wildfire spread and risk maps, as we talked about earlier. That's based upon our historical data. And in 2022, Bear Valley will be working to develop real-time mapping of ignition probabilities, also spoken to earlier in today's workshop. In regards to communication, Bear Valley maintains a detailed list and maps of AFN medical and critical facilities. This includes information on our key stakeholders, first responders, regulators, and various state agencies. Bear Valley has no disadvantaged communities. By definition, it's essentially one community. When it comes time to communicate our PSPS emergency event, should Bear Valley ever have one, we do have a customer portal, which includes our GIS maps, IVR, two-way text capabilities, website updates, news releases, social media, and direct mail campaigns. And where applicable, we do communicate all of this information in multiple languages. We do host a couple of community outreaches each year, and we do work with our CBOs to disseminate useful PSPS information. You can also see here, as I've taken some excerpts out of our detailed PSPS plan. You can see the chain of responsibility. We do have multiple titles. For example, the president is also the incident commander during any PSPS emergency. We also have ready and available to stand up a community resource center. And an extension of that program is the portable battery program, transportation support, and lodging capabilities should we need to provide that to the community of Bear Valley. As I mentioned, we did not have any PSPS events in 2021, and based on analysis that we have conducted of weather in the last 5 years, we did not reach any criteria to invoke a PSPS event. In regards to reducing the scope and frequency, Kevin, you mentioned that earlier on. The next few slides basically just reiterate some of our wildfire mitigation plan. We do believe that once all of these components come in into fruition, that it will reduce the likelihood of a PSPS event. Next slide, please. You can see that we have identified the high-risk areas for PSPS consideration. Those are the areas they're highlighted in the pink color. Next, we see that Bear Valley is planning a couple exercises here on slide 6. We did have a tabletop exercise in April. And coming up here in June is Bear Valley Electric Services inaugural functional exercise. So the primary goal here in June is to conduct an exercise that closely mimics a real event and to further stakeholder awareness, which has already been improving through some of our surveys that we have been conducting, as well as understanding our strengths and weaknesses and implement our lessons learned. Bear Valley does have a well-established working relationship with many local agencies, such as the fire department and police department. And this exercise here coming up in June will be an opportunity for us to improve our community member awareness, coordinate with the forestry, CAL FIRE, San Bernardino County, and neighboring utilities, such as Southern California Edison. The next few slides, we can just kind of take a cursory look. There's 4 of them. It's just really a recap of some of our initiatives that you've seen or heard about already. Some of the covered wire program. On the next slide, how we are investing in safety. Our investments in safety reduce the likelihood of a PSPS event in the future. Of course, BVS wants to protect its residents and customers from wildfire risk while maintaining reliability. That's really our goal. And that's why we're investing in covered conductor. We have replaced all of our conventional fuses. We have improved our situational awareness through cameras and weather stations and other efforts. You can also see some more of our programs here on slide 9, talking about our asset management, inspections, veg management program, grid and operations, and then on slide 10, data governance, our resource allocation, and emergency planning and preparedness. That's all Bear Valley has in regards to PSPS. Looking forward to the Q&A session.
Thanks, Sean. Appreciate it, as well as the other utilities. At this point, I wanted to turn to our stakeholders on the line and see if there are questions that you had in mind for this session.
I think you have one hand raised, Justin Hagler. I know if the panelists don't have any questions, you might want to go to him.
Thanks,
allow
Adrian.
Justin to speak.
Go ahead. Go ahead, Justin.
Hello. Okay, that looks like it worked. Actually, I think I was supposed to be a panelist, so but I can do it just this way. Yeah, so I'd like to thanks for the presentations. I'd like to start out by asking, PSPS events can be, quite difficult for your customers. So can each utility speak to the state of how you're quantifying the risks and harms to your customers caused by a PSPS? How far along is that program? And can you give us any insight into what sorts of values are taken into consideration when you're looking at that?
And we can go in the same order as presentations. Thanks, Alan.
Yeah, sure, thanks. At this point, that evaluation is more qualitative, right? That's us through our outreach to the communities, the tabletop exercises, trying to understand the impacts to the community of what a de-energization event looks like. It's not quantitative. We don't quite have a metric of like, well, how do I view either that risk of not having power? Is that a financial loss? I mean, or some other type of risk being created? How do I create a metric around that? Don't quite have that. It's more qualitative of just gaining that understanding of what are the impacts of the de-energization for a community.
Yeah, and I would say, Liberty is in a fairly similar boat to what Alan from PacifiCorp just mentioned. It is a bit more qualitative for us at this point. We certainly know and have spent a lot of time, modeling our risk from the standpoint of what could happen if the fire does start and what potential impacts that can have. But as far as the impact to customers with the de-energization, it is a bit more qualitative. This year, we do sort of want to develop that a little bit further, start to take a look at, the number of AFN population, critical facilities, and those types of key customers that may be impacted by an outage. And then, obviously there's some work that needs to be done on how to quantify those impacts. And so, yeah, that's pretty much where we're at with it as well.
Justin, similar for Bear Valley. Bear Valley has never had a PSPS event, so really the risk modeling is tied to the previous section that everybody was talking to in regards to fire spread and risk. And so it is more focused on the community communication and planning for such an event, should we ever have one.
Got it. Thank you. And as a quick follow-up, is specifically Bear Valley and Pacificor, are you planning to start to work towards a more quantitative examination of harms and risks to customers caused by PSPS?
Yeah, I think it's through that risk modeling of the fire simulation and those tools to understand, well, what would the impact have been if a fire started, and then, you know, the absence of that fire. That type of risk modeling is the first kind of evolution of those metrics, is where we'd like to grow.
Justin, I appreciate the point that you're making, and we'll definitely consider it. You know, Bear Valley has a very small service territory, very small. So I think what's probably more probable for Bear Valley is that there's a Southern California Edison PSPS event that affects Bear Valley service territory, rather than one where Bear Valley invokes one themselves. But you're right. Based on a really small customer base, it is definitely a different dynamic, because the center of the community is really where everybody's clustered and very accessible. We have the Bear Valley Power Plant, which can serve as a backup source of generation should we need it. And the Community Resource Center is centrally located. And so on a smaller scale, we just haven't really dove into that type of analysis as of today, but we'll certainly consider it.
Thank you for those answers. I've got plenty more questions, but because I'm not officially a panelist, I'm not sure what the question queue looks like. So I'm happy to trade off with others.
Justin, give me a second. I'm going to promote you to panelist.
And then I wasn't sure if Liberty had jumped in on that last round.
Sorry, trying to come off mute there. So I think the question was, you know, are we planning on for further developing our analysis for that? And I would say the answer is yes. You know, we have looked again at the risks of the fire that could start, but in addition to that, you know, we've looked at the likelihood of PSPS, you know, looking back at historical weather events and, you know, determining, you know, what conditions and how often, you know, we might anticipate a PSPS itself. But, you know, like, as I said earlier, I think, you know, our next step here later this year is to start looking at some more of those key factors on impacts to our customers, you know, especially vulnerable populations, as well as you know, our critical facilities, and all of that, and trying to find a better way to quantify that.
Thanks, Elliot. And I just had a quick follow-up with Bear Valley. You mentioned that you had looked at, you know, past data, but are you also considering future scenarios?
Absolutely. Yes, that's the reason for a lot of our tech upgrades and things like that. What's interesting about Bear Valley building to those higher alpine conditions, and basically we've been grid hardening our system for a very long time. I think we just don't see the wind, which is one of the contributing factors, obviously one of the main contributing factors to any PSPS emergency that a utility would invoke. We're just not seeing it down at our pole level. That's possibly due to wind break and things like that. That's kind of just relative to the area, plus the way that the Santa Anas and the timing when we have our high winds, it's really in the winter, those kind of things being off cycle from really the rest of the grid. So it does kind of create a unique scenario for Bear Valley. Every time I say that we've never had a PSPS event, we kind of stick out. So it's always worth mentioning that there are some unique circumstances around our service territory up there, Kevin.
Yeah, no, not to follow up too many times, but what your response made me think of the slide that you showed, identifying certain areas that were more risky than others. And Is that playing into your answer here at all?
Yeah, these areas we've had identified for quite some time. This goes all the way back to tying into some of the other information you heard earlier today. That's all on slide 5. It kind of shows some of our what we consider to be the kind of higher risk areas. We've certainly been concentrating a lot of our wildfire mitigation plannings involved with these circuits. I believe it's around 6 circuits or so that we primarily focus on. And yeah, those are kind of areas that we concentrate around the most. That's right.
Okay, thank you. And I can hand it back to you, Justin. You're free to ask more questions.
All right, thank you. This one's for Sean. So could you speak a little bit more on the extent to which Bear Valley is coordinating with SoCal Edison on their risk of de-energizing the lines feeding the Bear Valley service territory?
Yeah.
And specifically, I'm interested in, have you got a sense from them how severe is the risk? Like, are they saying, you may be under 3-4 PSPS watches a year, or is it expected to be a relatively rare occurrence?
We are under PSPS consideration from Southern California a handful of times per year, yes. And so every time we go out to our community, so far it's been directly related to Southern California Edison's potential PSPS event. We are in very close communication with them. We do participate in each other's outreach events, so we'll attend their exercises, and we're on all their local outreaches that they do quarterly and things like that. So we are in close coordination with them, as well as with our account holder, and they attend ours as well, Justin. So yes, there's close coordination there, and about half a dozen times a year or so, I think they put us under PSPS consideration approximately.
And brief follow-up, I know that in your WMP, there's kind of a chart of, if this happens, then we do that. Has it gotten to the point where you're seeing the most severe outcome in terms of circuits feeding into Bear Valley all being cut off, to the point where you'd be concerned that these rolling blackouts would have to happen?
We've gotten close to not all 3. I think maybe that may have happened maybe one time some years ago, but since then, since the fire rating systems and things like that and the districting, it's kind of changed a little bit. It's gotten better.
Nice.
Yeah, it's not really so much of an issue.
Thank you. I appreciate that. Kevin, should I keep talking, or are there other questions on the line?
I have some, but feel free to go ahead.
Oh, no, I'm happy to switch off.
All right. I guess to that end, with regard to the exercise planning, and this is for Bear Valley as well as the others, but it's glad to hear that there's a lot of coordination going on with SCE, and just curious for Bear Valley how much SCE is engaged in the big exercise coming up, and then for all utilities, I wanted to hear some of the lessons, key lessons learned from exercises that have your most recent exercises.
Yeah. Well, Kevin, I'll go ahead and start since you did mention Bear Valley. Yes, they will be attending our functional exercise. So historically, Bear Valley has only had to do the tabletop. So this will be our inaugural functional exercise. So our plan this year is to layer on, basically take the same scenario to which our team had talked through in April, and to really expand into and to do more functional aspects of it. Now, in the past, there were some kind of hybrid approaches that we'd done on our own, but this time, yes, it is a full functional exercise. So we do either hot wash or have a debrief after any of those exercises, and we do incorporate all of the lessons learned into the next event. And so actually tomorrow we're having one of our quarterly and some of the final planning for the June 21st functional coming up, and Southern California Edison will be in attendance there as well.
I know you have an extensive, PSPS plan that was included with the WMP have lessons learned affected the plan? Has it been updated based on some of the lessons learned, or has that affected the plan?
Yes. There has been some minor modifications, yes, and lessons learned. And it's usually around the flow of the exercises, identifying some of our shortcomings. There has been some, and that's usually in regards to some of the Cal OES notification processes and things like that. We didn't really talk a whole lot about that in April, so we planned some additional in-house meetings to really bolster those positions, make sure that we have a real clear understanding on how to engage and send notification to both the CPUC and the Cal OES, including all the standing briefs that we have to make at the state level as well.
Appreciate it. Thanks, Sean. And Alan and Elliot, any lessons learned from recent exercises as well?
Sure, I'll jump in there. And I guess I'll also note that we have a connection transmission, but with PG&E, and so we do participate in their tabletop exercise as well. So that gives us an opportunity to see how they run their exercises, and what we can grab from that and running our own exercises is beneficial as well. As far as out of our tabletops, what came out of that is the services at our CRCs, and what can be provided, what our communities need, and so being able to review that and add to those services, the coordination with our telecoms and looking to improve that as critical infrastructure, and what types of notifications or what that content should look like to the telecom companies. It has been a conversation, and looking for ways to improve that. Obviously, most notably would be through the establishment of our, the public safety portal and how to provide information through there. But that all came out of those tabletop exercises.
Thank you. And anything from Liberty exercises?
Yeah, good afternoon. This is Lee Kilbasa, emergency manager speaking for Liberty Utilities. And some of the big things that have come out of our exercises, and also we had a near miss event last September. And of course, we held hot washes and cataloged our lessons learned. And one of the things that we came up with was that we have a playbook that summarizes all our communications efforts and roles for each one of our incident command members. But from our lessons learned, we decided to streamline that playbook, and we've recently done a rewrite of our public safety power shutoff playbook, and we'll be exercising that in an internal exercise on May 25th, and then in a full-scale functional exercise with our public safety partners on June 25th. Another thing where we got a lot of lessons learned were we tested our community resource centers as part of the PSPS. We had a close event in September last year. We mobilized 3 of our community resource centers, and we got a lot of good feedback and lessons learned that we've kind of taken to heart, and we've been working on over the winter and this spring. We've added a number of additional community resource centers and additional resources for the community resource centers that we would be able to deploy. Also looked at some of the staffing considerations, what it would actually take to staff them from the hours of 8 in the morning till 10 at night. So incident command, public safety power shutoff playbook, and community resource centers. We've really gotten a lot of useful lessons learned.
Thank you. Was that last point with regard to staffing resource centers or EOC?
No, staffing the community resource centers. We staff. We've looked at contracting them out, but we decided that the best option was for us to staff them internally. So we have internal staffing for each of the resource centers, and so we've looked at training for our staff, so they know what to do to staff them, and also staffing, union considerations, all those type of things to staff a community resource center, and then also working with the public on the CERT teams to get public volunteers to augment our staff at the community resource centers.
Very good. Thank you.
Sure.
I'll hand it back to you, Justin.
All right. A fairly straightforward question for me, the notification schedule. I think, Elliot, you mentioned Liberty's schedule. When the utility is forecasting their PSPS event, and the scope may change as weather forecasting gets more precise, are cancellation notices sent to the customers who are removed from scope as the geographic area of PSPS becomes more certain?
I'll go first, and so that's a great question, because that should have been listed as a lesson learned, is that notification process, because at the beginning of a PSPS kind of establishment, it was about that. All right, what's the notification window look like? 72 hours out if possible, 48 hours out, if possible. But then what happens as that forecast becomes more specific and more granular, you start then having to communicate to some customers, oh, you're no longer in a PSPS watch or event, but this other group is. And how do we do that without confusing the message, right? And so it is about those direct customer calls, if you will, and making sure we have that accurate, so that when we do those outbound calling, we can segregate out and make sure that message is clear, that almost like, yes, you were in a PSPS watch, you no longer are, kind of thing. And so that is something we've talked about, and we're preparing for that scenario. Haven't had a chance, obviously, to see it in practice, but it has been a conversation.
Yeah, I can go for Liberty. I'll be quick. The answer is yes, we do communicate, those scope changes or step changes to our customers. So if they, did receive communication that they're within, potential PSPS zone, and that changes, we will push communications to those folks.
And Justin, same for Bear Valley. Yes, that is the plan.
Sorry, yes, it's planned, or it's already been implemented?
Well, we've never had a PS
yes,
event,
but
yes,
of course.
That is
Yeah.
that is the approach that we will take. That's correct. Mm-hmm.
Nice.
Refine the communication.
Nice. Elliot, have you had any customer feedback on if the message was confusing? Because I can certainly understand that aspect.
I'll try to answer that, and then Kate, if you want to jump in on this too, if you have anything to add. To my knowledge, we haven't received a whole lot of confusion on our near miss events as it pertains to Liberty's intentions. What also happened during our last, I guess, near miss event that did cause quite a bit of confusion was at the same time that we were, concerned about the weather in our service territory, so was NV Energy. NV Energy is in Nevada, obviously, but they're our primary service provider. We get our power from NV Energy. They have a program in place called Public Safety Outage Management, which is essentially the exact same thing as a PSPS that we call here in California. So there's, we've worked with them and, talked with them quite a bit. We've participated in their training exercises, but there is potential for them to conduct a PSOM on transmission lines that would impact Liberty's customers. And so it did create confusion when we were trying to relay a message of what NV Energy's intentions were, as well as what our intentions were. And I think people had a difficult time, separating the two. And so, we are, working to try to clear up those communications as best we can.
That's really interesting. Thank you. I did have one more question. The Liberty's 211 program and PacifiCorp's generator rebate program. For the generator rebate program, do you have any rough statistics on customer uptake on that program? Your battery program seemed to have really good metrics. I'm curious to see how that compares to the generator program.
So the generator program has not been taken advantage of by our customers yet. It's low numbers. And so it's really emphasizing the fact that we need to somehow beef up that customer outreach to let them know that the program exists, because we're not seeing the numbers. Yeah, it's low adoption right now.
And that's compared to the battery rebate program where you did like directly outreach to customers on that.
Correct, because with the approach with the battery program was to have us contact them and sign them up for the program.
Nice. Yeah, I think that just the second part of the question was for Liberty on its 211 program. Was that implemented recently, and have you seen any customer engagement with it?
Hi. Okay. In terms of 211, we're really in the stages of trying to understand how the service varies so greatly between all counties that we serve. Unfortunately, Plymouth and Sierra County in the north don't yet have 211 set up. The remainder of the counties that we serve do. But as mentioned, the level of service provided or the resources available just vary very significantly, really. So the most, I would say, supportive relationship that we've kind of managed to find with 211 currently is in the Nevada and Placer areas. A really robust 211 connecting point service, and we involve them in our ASN preparedness planning and the exercises Lee and Elliot had mentioned. So we are looking into more information around their care coordination programs, where they may offer them. But really, it's been a really helpful resource to understand what is available in some of our more rural areas, just what does and does not exist. And also, to complement that, our relationships with community-based organizations have been largely helpful as well in areas that don't have 211. If that answers your question.
It does, thank you.
Thank you. I wanted to do a quick time check with Adrian, see how we're doing.
Yeah, I think we're getting very close to the point where I was going to say we have to stop. We have about 3 minutes to the time that I was going to say we should cut it off. Yeah, I guess maybe we can do one last question if somebody has one, if Justin or someone has another question. Otherwise, we should go ahead and take a 10-minute break and then come back.
I'll try to contain my excitement and advocate for the break.
Okay, thank you, Justin. All right, so we'll take a 10-minute break and come back at 3:38 now.
Thank you all.
Thanks.
Okay. Looks like it's time to move on to the next panel. Is Andy or Brian available? Andy? I guess that's
Yeah, I'm here.
you. Cool.
Yep.
Why don't you go ahead and lead us off then?
Okay,
Thanks.
sounds good. Hi, good afternoon, everyone. I'm Andy Biggs. I'm a utilities engineer for energy safety, and I'll be moderating today's final session on asset management and data governance. As part of properly assessing risk, it's vital that the utilities have frequent and thorough inspections to understand asset health and accurately identify where to conduct repairs, replacements, and system hardening projects. Utilities also need to have practices in place to accurately collect, manage, and maintain data to inform its initiative practices and selection. With that, I'll now turn it over to the utilities, following the same order as before. So starting off with Amy McCluskey from Pacific Corp. And then again, as a reminder, please feel free to use the Q&A function to type any questions you have in, but we will leave any answering to questions till all utilities are presented.
Thank you, Andy. Good afternoon, everyone. For those who may not have been on the call this morning, my name is Amy McCluskey, and I'm the Managing Director of Wildfire Safety and Asset Management at Pacific Power. I'll now be reviewing our 2022 Asset Management and Data Governance Update. Once again, when we get to the questions period, I'm joined by a few of my colleagues who may be supporting with some of the answers. Next slide, please. Just as a quick refresher, out of respect for time, I'm going to go quick through this one, but I just wanted to give folks a sense of our service territory. Scale sometimes matters for things like asset management programs and data governance. And so moving left to right, we have our general service territory, which is around 45,000 customers and around 2,500 miles of distribution and 800 miles of transmission. This is where we tend to perform system-wide initiatives, such as weather stations, situational awareness, community education and outreach. Moving left to right, the next kind of bucketed area is our HFTD. That's where you see a lot of programmatic shifts, such as some of our targeted asset management initiatives or the vegetation management work that Brian reviewed with you earlier today. And then all the way on the right, PSPS zones, which is where we target a lot of our grid hardening activities, which was included in our presentation earlier today. So that just kind of gives you a general scale of what we're talking about and the three different sort of buckets of our assets as we think about asset management and data governance. Next slide. In 2021, as part of our asset management programs, Pacific Power completed our traditional and routine programs consistent with GO 95 and GO 165. So as a part of these programs, we completed detail and patrol inspections of approximately 4,200 line miles. Some of those are overlapping line miles, so we may come through and perform a detailed inspection and at a different time perform a we identified through these inspections approximately 7,000 conditions for correction, and in 2021 corrected over 13,000 conditions, many of which were corrected as a function of the line rebuild program, as well as opportunity maintenance or individual correction work. And those corrections could vary in kind of size and requirements. So it could be things like high voltage signs, or it could be broken ground rods, or it could be pole replacements. We also completed enhanced IR inspections on 700 line miles of overhead transmission and identified through those enhanced inspections 2 conditions for correction. In 2022, we're planning to continue with the existing programs, which do target additional inspections and accelerated corrections in the HFTD, which I'll touch on in a future slide, and further develop the distribution IR pilot. So the goal of this pilot is to take these lessons learned and these good things that we're finding with the transmission IR inspections and see how the same tactics can improve our distribution inspections. Next slide, please. All right, so here's the asset inspections. And so we do have a program shift in the HFTD where we have an increased inspection frequency and accelerated condition correction timeline. These programs generally include detailed inspections, which require someone to stop at every facility, do a detailed walk around, a detailed inspection, as well as patrol inspections, which are meant to be a little bit quicker in nature and look for significant safety hazards. Once again, those are performed on an increased frequency in the HFTD. As far as correction of conditions, we also perform those on an accelerated timeline in the HFTD, specific to the fire threat conditions that we find, depending on tier and priority. You can see the general volume of conditions on the slide as well. Just kind of for reference, our top 3 are our kind of heavy hitters, if you will, on fire threat conditions that we tend to find and correct most often. They fall into one of 3 categories: pole replacement, broken or damaged insulators, and then split or damaged crossarms. So those tend to be things that we find more often than other types of things. Additionally, we plan to continue IR inspections of overhead transmission lines. In 2021, as I mentioned, we identified and corrected 2 non-traditional conditions, what I'll call them. So conditions that we found using the IR technology, so nothing visible to the naked eye, but apparent using IR technology. So far in 2022, we have found an additional 2 conditions so far, and correction plans are underway for those conditions. They tend to be a splice type condition or a jumper type condition. And so what's great about using IR is that we can assess the condition of the splice or the condition of the jumper prior to failure and do a proactive replacement. Next slide, please. Pacific Power is also looking to build upon existing data governance and reporting capabilities. Data governance generally involves the collection and evaluation of data from multiple data sources to inform decisions and measure and report progress. As described on the previous slide, it's important to all programs, so it's not necessarily targeted in one area of our service territory or another. It kind of applies to everything we do. Given the criticality and challenges involved, in 2021, we're bringing on an additional resource to support GIS data mapping and a lot of our quarterly filings. We've also put in additional processes to review data prior to report submissions. And we recognize the importance of data quality and growth in these areas and want to continue expanding our capabilities. Additionally, beginning in 2021 and now continuing into 2022, we're building a new wildfire safety team within our T&D operations organization. This team's not California specific, but does support operation in all of our Pacific states and reflects a dedicated team to manage and monitor collective implementation of our plans, which is really helpful because this team coordinates across many departments and ensures alignment on all of our programs. And with that, I think that concludes the presentation for today for Pacific Power's asset management and data governance. So I hand it back to you, Andy.
Okay, thank you so much, Amy. Next up, we have Blaine Ladd and Elliot Jones with Liberty.
Okay, thanks, Andy. Blaine Ladd with Liberty here. I'm the Director of Operations, and for my backup, I have Elliot Jones, Senior Manager of Wildfire Prevention. Today, I'll be talking about asset management and data governance for Liberty, primarily focused on our inspection programs and how we manage that data. So next slide, please. So historically, Liberty has complied with GO 165 requirements in our service territory. Since we're all high fire threat district, it's a 5-year inspection cycle. But since 2020, we've tried to make improvements to our inspection program, and that's what this slide kind of talks about. So in 2020, as we discussed back in our grid hardening section, we completed inspections on the entire overhead system in 2020 and logged that all into a database. And so this database is app-based, so that allows us to install it on iPads and smartphones so that it's really easy to use in the field and input data and then get it over into our database so that we have that for record and proof of compliance. We've also, I'm sorry. So this leads to better knowing where issues are, what is the criticality of the issue, and then if it's in high fire threat zones, like a tier 3 area or one of our higher threat areas based on our risk mapping. We've also in 2022, we implemented a QA/QC program for our inspections, and this will be done by a third party coming in to validate our inspections, making sure they were done correctly and thoroughly, that we didn't miss things, and that they would come in and QA/QC a percentage of our GO 165 inspections done for that year, our detailed inspections. Going forward, we're evaluating revised inspection timelines based on our risk mapping, modeling, and our threat zones. For instance, we would probably go from a 5-year inspection cycle to more like a 3-year inspection cycle for those particular areas that are higher fire threat. And then going forward, we'd like to look at applications for infrared imagery. We to date have not implemented that technology in our inspection process. Next slide, please. And so just to talk a little bit more about our total system inventory, it was completed in 2020. As we said, we inspected all of our overhead assets and logged any issues per GO 95 requirements, and put a level to them, level 1 or 2 or 3. All the level 1s were taken care of as soon as possible. Level 2s we tried to get to within 6 months within our tier 3, and within a year outside of that. So this really gives us a baseline and feeds into some of our programs, such as pole replacements, just critical repairs from inspections, and identification of things like non-exempt hardware per CAL FIRE. And we could prioritize based on the area. And so this all feeds into a total asset management system used to identify and prioritize work based on fire risk. And in the picture, you can see this is the app that we use. It's real easy for the guys to just input the data, take pictures, before and after pictures, all go into the database. You can see issues very easily are color coded, and there's several different colors you can use. So it's a real neat system. We like it a lot. And that's really all I've got for asset management and data governance today. So I'll be here for the Q&A. Thanks.
Great, thank you so much for explaining. And then last presentation we have today is from Bear Valley with Tom Chow.
Hi, can you guys hear me?
Yeah, sounds good.
I'm the utility engineer and wildfire mitigation supervisor. You guys weren't at the first presentation of today. Next slide. So the traditional inspection program, as we all know, is a GO 165 patrol detail intrusive that we do. We do inspection yearly. Next slide. These are the list of the enhancement inspection program that we implemented. And they are LiDAR survey, got UAV, thermal. We also have a third-party ground patrol. We have a forester and vegetation QA/QC program. So next slide. So in 2022, our WMP initiative and targets are for the detail, we're going to do 29 miles. For the patrol is 255. The UAV, we're going to do 211 circuit mile. Same thing with the photo of the UAV. Intrusive, we're going to intrusive test 850 poles. LiDAR, 211 circuit miles. Third party ground patrol, 211 circuit miles. We also have the GEO 174 substation inspection. We'll be targeting 144 inspection. And then our veg management QC program, we're targeting 72 QCs that we'll be doing this year. Next slide. So we are in the process of centralize our database. We're currently using the iRestore program, which we have our distribution inspection it's live. The next two inspection that we're working on getting into the same iRestore program is the vegetation management, which will be coming this year, and the substation inspection will be coming this year. And we keep we have our geo database that we collected 4 or 5 years ago. We are using MillSoft software to keep our asset managed data in there. That's all I have.
Okay, thank you so much, John. Great. So now going into Q&A, I wanted to open it up to Holly Werman with Cal Advocates.
Hi, thank you. All right, so thank you for those presentations. I've had a few questions here. So the first is, for all the utilities, how do you prioritize and schedule and complete your inspections relative to the wildfire season? Do you try to target completion of your detailed inspections and patrol inspections before fire season, or are you performing those throughout the year?
Hi, Holly. This is Amy. Thanks for your question. Generally speaking, yes, we're prioritizing what we call our tier 2 and tier 3, which is our HFTD inspections on the front half of the season. So we try to get them done in the first 2 quarters. I believe, if I'm remembering right, there's one portion of potentially tier 2 that is on the later schedule, just to try and keep the California cycles. So we have to kind of keep it scheduled later in the year, but the majority of them get completed ahead of fire season. So we do prioritize that work.
This is Tom. We're the same. We try to, like, the detail on patrol, UVA, LiDAR are usually done in the first 2 quarters, and we're actually almost done with the UAV. Sorry. The substation inspection is we do it monthly, so it's a little bit it'll be done throughout the year.
And similar with Liberty, so our construction season kind of lends to doing more maintenance type of activities in the winter months. So our construction season within the basin, what we call dig season, is May through October. So in the off months, when our guys are not doing a lot of new business type construction, January through May, they're doing the detailed inspections and taking care of any high level critical items before fire season.
Thank you.
Yeah, thanks so much, Holly. Wanted to check with Zoe and GPI if you had any questions. Oh yeah, your hand's raised, so you can go ahead and take the floor.
I'll just ask one quick question. So what percentage of the inspections are going through the QA/QC process? And is that, I guess it's a longer question, is that done by external contractors doing QA/QC, or is that all internal?
Hi, Zoe. I assumed your question was for all the utilities. Is that? Yeah, okay. I'll go ahead and go first, I guess, to keep with the order. So as far as our detailed and patrol inspections, it varies a little bit, but in general, majority of our inspections are conducted by a contractor. So we have qualified contractors out there performing the inspections. A part of that contracted service is that they also have a QA/QC program. So they have senior leadership and experts within their company that are QA/QCing those results that come in. In addition to that, we have an internal department. We call them field inspection support. So it kind of has a similar vibe to the vegetation management program where we have a lot of contractors out doing the work and we're coming behind and kind of QA/QCing that with internal staff. As far as percentages, what we generally aim for is to field verify 5%. So that tends to be the QA/QC percentage, and take trends and things from there and apply them and work that into an annual training that happens in January. So we shoot for 5% at the pole. There's quite a bit more desktop exercise and desktop reviews that occur. I don't have those percentages offhand, but it is higher. So our team will actually look at pictures on paper and look at results on paper. But as far as going to the pole and actually having like a checklist and verifying, that's around 5%.
And for Liberty, we just, as I said, just developed that program this year. So we have 0.5% as our QA/QC, and that is going to be done by a third-party outside contractor with qualified electrical workers.
Hey, Blaine, to clarify, is that field QA/QC or desktop? Do you know?
That is all field QA/QC.
Thank you.
This is Tom. We're about same thing, 5% of QA/QC, and it's mostly internal. We have our field inspector. If there's any question, they would go out there and take a second look at it.
I would just add, we're doing multiple different types of asset inspections. So one of our inspections is a third-party independent contractor who does a ground patrol. We certainly compare that to our own ground patrols. And that's really a lot of the QC is, what are these different programs finding? And if there's a difference, why?
I actually have a follow-up question to that. I was curious what sort of success you've seen with the additional types of inspections, so with thermography and the UAV HD photos and LiDAR, and also wanted to ask Liberty and PacifiCorp if you, I know you talked a little bit about using infrared, but have you explored piloting any of these additional technologies for enhancing inspections?
Yeah, so we've used different technologies. We also use another one we don't talk about anymore, Exactor. And, the first round, we usually find more, but they start to wane. We don't have a lot of the connector corrosion problems that other utilities do due to where we're located. So on the thermography, we get some, but not a whole lot. The UAV was probably the biggest one where we saw a lot of initial stuff that we, just you can't see from doing a ground patrol. So, but I think most of these inspections, once you've done the initial one, the number of new discrepancies that you might find starts to drop off quite a bit. And so, right now we feel, especially with the LiDAR and what we're getting from the vegetation, which grows, right? So that's constantly dynamic. We see value of continuing those inspections. As far as the asset goes, you could probably increase the periodicity as you do it more often. But right now, at where we are, with grid hardening and the fact that we have a lot of bare water and we want to manage the vegetation, it's better to keep the frequency of the inspection at an annual rate right now. I don't know if that makes sense.
And I can answer for PacifiCorp and kind of continue on that same thread. So as far as kind of new technologies, we did touch on it a little bit in the presentation, the infrared inspections. That's been primarily on our overhead transmission lines, just because the method of collection using a helicopter is fairly cost effective. The technology is very mature. We have had year-on-year success. What we have realized is it does take a decent amount of coordination to capture those infrared results when the loading is highest on those lines. And these are still transmission lines, so they're not incredibly loaded, but we do want to make sure we're catching them at more peak load just to get a better reading. And so that has gone pretty well. We've seen year over year success, if you will. We've seen new things each year. But to Paul's point, we're trying to keep an eye on that because maybe annual isn't needed forever, or maybe more than annuals needed. I'm not sure that the periodicity, we've yet to completely nail down what makes sense. We kind of just keep inspecting. And if we find more things, we keep inspecting. But so far that's been pretty good for us. Our big thing this year is to then take that information and those lessons learned and see how it would apply to our distribution system. So we're excited to see how that works. Some other companies, I think some of the larger IOUs have had some success in that space. So we're still trying to figure that out. As far as other technologies, UAVs, we've only used those on I would say, as needed basis to investigate something. On kind of our large scale, we've had a hard time finding a cost-effective way to use drones for inspections. But certainly it's always interesting to hear what others are doing and if they're finding success with it. LiDAR, we did try a little bit of that out. If you were in the vegetation management section, I know Brian touched on it. What we had a hard time with was taking LiDAR and getting quality asset information that then we could operationalize, that we could turn into an action, turn into a decision, turn into some sort of work. So I think in that space, we're waiting to see the technology and more the application of the technology mature. And I think that's for the most part, the, inspection technology suites that we've been experimenting with or considering. So hopefully that answers your question.
Yeah, thank you so much.
And for Liberty, since 2020, our main focus has been sort of getting all the repairs and replacements done from our system survey. Like we said, we are going to explore infrared going forward. We do use LiDAR, as mentioned, for vegetation, but we looked at it from an asset point of view. It seemed pretty labor intensive to try to look at all that data and find issues, and we found that just boots on the ground approach seemed more reasonable and not so expensive. We do have a couple of drones in our inventory that we use to date, not so much for inspections, more for reactionary type of scenarios.
Yeah, thank you so much. So planning on turning it back to Holly, but did want to check Adrian. I know we're a little bit off schedule right now and had the intention of opening it up to further questions. Did you have a time in mind for when you would want to do that, or should we just continue forward with the Q&A as is?
Yeah, I think we've used up a lot of the period that we had at the end here for open discussion, other questions, for questions during the previous panels. You had about 45, 50 minutes at most, I think, for this particular panel. So I think you can just keep asking questions until it's all done. We'll probably still end around 4:30 today, although we might do a little small Q&A at the very end.
Okay, sounds good. Yeah, so with that, I'll turn it back to you, Holly, and then also just wanted to remind participants that feel free to use the Q&A function for any questions.
So my next question is about root cause analysis and how that, how you use that, or if you use it to inform maintenance of assets. So for example, if there's a risk event, an outage or an ignition or what a wires down event, do you conduct any root cause analysis activities to understand why the asset failed, assuming it wasn't something obvious such as a tree falling, and use that analysis to inform your maintenance as well as to improve inspection processes to attempt to identify and repair similar issues in the future? So I'd like the utilities to speak to that.
Yeah, hi, Holly. So this is Amy again. We have a couple different ways where we do this. The more traditional way the utilities been working with this is what we call through a material failure process, material failure analysis. So when we have an outage like you're describing or material failure, we do collect the sample, we collect the information, and then our engineering standards department kind of runs it to ground to understand why did it fail? Is there something deeper going on? Traditionally that has resulted in changes to engineering designs and standards, changes to recommended manufacturers, parts, things like that. So traditionally that information becomes kind of forward momentum on how to do better in the future. Where I think we're trying to do more is to take that same process, but then almost look at a trend analysis and say, okay, well, do I need to do anything different? Should I been doing something different from a maintenance and inspection perspective? Now that I know I'm designing it better, is there also something I should be doing different to my inspection practices? I don't think we're quite there yet to kind of connect that full circle, but we do have a fairly robust material failure analysis process, just not that trend analysis and kind of feedback loop that you're referencing.
So for Liberty, I wouldn't say we do root cause analyses on these system events. We do for any kind of a safety related issue, certainly. But if it is an event that caused an ignition or possibly could have caused an ignition, we do I think a pretty thorough investigation, and maybe Elliot could speak to that a little bit more. But and then we would hold hold training on what went wrong, so our guys know what to look for when they're out in the field. Certain pieces of equipment sometimes we'll send back to the manufacturer for an analysis to see why it failed, and they actually do an RCA on a piece of equipment. For instance, right now we found a splice that had holes in it, and it looked like it was about to fail, and I'm trying to send that back to get a better analysis done on it. So I didn't know, Elliot, if you had anything to add to that.
No, I think that pretty much covers it, Blaine. Yeah, with the with ignitions and those type of things, we definitely do an investigation of those and track those in our database. But nothing more to add. Thanks, Blaine.
Yep, thanks, Elliot.
For Bear Valley, we do use the root canal analysis as needed. Like for example, we had a pothead failure. We were trying to figure out why it failed, and ultimately we found out that the termination kit, the sleeves had different length, and they're not always manufactured the same. So, and we eventually conducted training with our linemen, our crew, to know what to look for in the future and what not to do when they're installing the pothead. And And it's the same thing as the other utilities. There, for when there's a failure, then we look into what caused it, and if we need to use the root cause analysis, then we would look into it.
Yeah, and in that example, just so for those who don't know, pothead's the connection that goes from the overhead to the underground. So that's what that's referencing.
Yeah, thank you.
Okay. Thanks so much. So I know earlier you said you had one question, but just want to check if you had any more.
I'm all set. Thank you, Andy.
Great. I had a question that's sort of built on what Holly asked earlier about prioritizing in advance of fire season. And this is kind of a two-part question. I was also curious if you were using your risk analysis to inform any sort of prioritizations of inspections. So for instance, evaluating like if there's a riskier area, would you go in and that's how you inform whether or not you're going to do an IR inspection, or if like increase the frequency of detailed inspections? And then additionally, I know you talked about how more frequent inspections are occurring in high fire threat districts, but was sort of curious if you've augmented your detailed inspections at all, like the inspection lists and such, to directly address additional wildfire risks. So kind of look for particular issues in field that may need to be addressed. So dealing with like a broken cross arms and kind of specifically looking for anything that could lead to an ignition.
Sure. So your first question around prioritizing inspections and if our risk modeling impacts the inspections and where and how we perform them. In general, we're using the California fire threat map. And so we're performing our inspections aligned with the general orders. And so it's very much a, based on tier 2 and tier 3. Are you on a 5-year detailed cycle versus outside? You might be on a 10-year. Same thing with your annual patrols. It's annual inside, 2 years out. So that's the main reason or the main use we have kind of for that risk assessment and how it informs the inspections. For the IR inspections, it's a little bit different. And so what's tricky about them is that we're targeting loading conditions. And so we have to find whatever time of year it is that the transmission line is going to experience the higher loading condition, because it gives us that better chance of success of seeing that anomaly. And so those tend to be spread out throughout the year. And so we kind of have bundles of them. So those aren't necessarily based on risk. We're not prioritizing them for that. We're prioritizing them for effectiveness to be able to see things. As far as and I'm trying to remember, your next question is around the inspections themselves. So we haven't necessarily augmented, I would say, what people are looking at. We've reinforced the concept of fire risks and fire threats in our training. We have changed the way we categorize, prioritize, and emphasize, I would say, once the results are coming in. And it's things like cross arms. Maybe those traditionally we could have taken longer to replace. Now they become accelerated because they get automatically flagged as a fire threat. Big circles, big checks. Everyone knows they're on the top of the list and you have to work them quickly. So our changes have been more around how we manage the work and manage the records, not necessarily what people are looking at, but there is an emphasis on it. So hopefully that helps answer your questions.
Yeah, it does. Thank you so much.
And for Liberty, so we are using our risk analysis, more specifically our risk mapping, to inform where we want to sort of escalate our frequency of inspections going from a 5-year cycle to a 3-year cycle. So yes, we are using that to make those decisions. And then as far as what they're looking for, aside from just normal GO 95 infractions, they are looking for obvious things that could cause a fire: broken cross arms, split poles, and any number of things that the the crews feel could be a hazard. And also we started asking them to look at CAL FIRE non-exempt hardware and identify that, so that we can develop a program here to start replacing a lot of that hardware.
And then Bear Valley. For Tom or Paul.
Paul, did you want to take this question?
Yeah, I don't think we really have anything to add here.
Yeah.
I guess, what are you using to inform sort of the additional inspections that you're performing?
Well, you mean as far as why we're doing them?
More so like prioritizing based off of location or
Okay.
where you're performing them.
So we get that question a lot, and we do use our fire safety matrix to prioritize it. But once again, we're a very small utility, 211 circuit miles, 32 square miles. You can subtract out about 8 square miles of wet lake and dry lake. So it's just more effective if we're going to have a UAV in the air to just do the entire service area. Same thing for LiDAR. And so we do prioritize to get it done before fire season. And so with enough time to go investigate any discrepancies that may be of concern. But you know, that's where the prioritization occurs. The detailed inspections are on a 5-year basis as guided by GO 165. And you know, we're looking at that one as something, maybe detailed inspections should be more frequent on the higher risk circuits, and maybe some of the lower risk don't need to be 5 years, but we're sort of stuck with GO 165 as far as the minimum. We could always inspect more than what GO 165 requires.
Okay, thank you. I'll turn it back to Holly if you have any more questions.
Yes, I have one more inspection question, and then if we have time, I have a couple of other more general questions that maybe would come up in the general discussion. So let's see, I think Liberty and just now Paul were talking about looking at increasing the frequency of your detailed inspections beyond the 5-year minimum mandated by GO 165. PacifiCorp, I'm curious if PacifiCorp is also looking at increasing that frequency, and just any sort of considerations around increasing that frequency, especially in the HFTD beyond the minimum frequencies.
Sure, Holly. You know, nothing concrete. Right now, we've just been kind of sticking with the, you know, general order requirements, aligning with those programs. You know, where our main changes have been is more in the diagnostic technology we're using. So that's kind of why we're trying to experiment with IR and kind of change the way we inspect. I would say with the exception when we do the transmission IR inspections, they are incremental. And so when we do those, that is an additional inspection. And so by doing that additional inspection, we are increasing the frequency of our transmission patrol inspections a bit more than the general order would require. That's more because we're trying to use the technology, but it does result in a even smaller frequency, I guess you might say, or more frequent inspections.
Thank you. I guess if Bear Valley or Liberty have anything to add on that subject, I'd be interested to hear it, but I know you've both spoken a little bit about it.
Yeah, I would just say, well, as far as the patrol goes, we cover everything actually twice, once by our crew and once by an independent contractor, who, by the way, does no repair work on our system. That's another requirement so that they don't have an incentive to give themselves business. And they're more an objective inspector. And then so you know, that one's not really going to get you much more. The detailed inspection, you know, that's more the hand over hand inspection. It takes more time and more resources. And so that's the issue. We'd have to expend more to increase the frequency of that on the higher priority circuits. But there is no, so it's either, you know, spend more to do more detailed inspections. Another approach would be to say, for example, underground circuits, they don't need to be inspected as every 5 years. Maybe they could be put out to 10 or 8. And therefore we've got more resources to concentrate on the bare water circuits. You know, those are things that would be good to have a discussion with the commission on as we review GO 165. So, you know, in the other industries, petrochemical, you don't inspect every pipe in a refinery. You only inspect the ones that have high probability of failing and causing a fire. So you wouldn't inspect water pipes, steam pipes as much, right? Same concept could be applied here.
Yeah, I don't have a whole lot to add to that, but I would just say that we are using, you know, the tier 3 mapping area and also our risk modeling and mapping to inform the higher frequency inspected assets.
Okay, thank you.
Yeah, thank you. Let me check with Adrian.
Yeah.
So I know we're coming up on time.
Yeah, we're coming up on time. Holly indicated she had a couple questions. If you want to go ahead and ask those questions, we'll go a little over time. Also, if any attendees have any questions, they should go ahead and raise their hands now. We will go just a little while over while you ask those questions, Holly.
Yeah, I'll try to keep this brief. So I have 2 questions related to resource allocation and planning. The first one is just a general question on how and whether your WMP initiatives have been impacted by supply chain issues, COVID, rising fuel costs, et cetera, over the last couple of years. And if it has been impacted by those, you know, what your strategy is to address those impacts.
Holly, I can answer for PacifiCorp. I think most of the utilities would probably agree we're certainly feeling the pinch of supply chain. You know, we've had to think a little bit differently in certain avenues. You know, we've had to change who our suppliers are sometimes, bulk order, try and get ahead of it. You know, so far we haven't seen that direct impact on our wildfire mitigation programs. We've been able to kind of level load and manage that inventory over time as far as supply chain. We've had kind of some other hiccups with project delivery. So nothing yet has really materialized, but certainly very mindful of it, feeling the pinch, feeling the pressure that comes from that. One area we are looking to make a change that will hopefully help with some of that is that contracted partner strategy that we're trying to push forward under our grid hardening is, trying to bring on a partner to help us, with additional materials management, with additional supply chain issues, additional resources, construction resources, engineering resources, to help us kind of scale up quickly and ebb and flow as we need to. We're still a ways out from having that partner on board, but in theory, that should help kind of soften some of that pressure that we're feeling.
For Bear Valley, I would say supply chain obviously is, affected us like everybody else, trying to get materials. The good news is we've been doing this for a while and have a good partnership with our vendors. And so we've been able to order things pretty far out, but when you order specialized equipment, that's made to order and it takes a while. On the COVID side, we've felt both. We've been impacted by contractors who had to delay work due to their crews or employees being infected. We've also experienced, especially in the beginning, huge jump in efficiency because there was no one on the roads. 2020 was probably one of our best production years. And a lot of that had to do with, it just was a lot easier to work.
This is Rick with Liberty. I'll comment that supply chain has affected us. It's basically added delays on getting our materials. So we're having to adjust and start things earlier. Transformers are by far the worst issue. And we're doing lots of work to deal with that. In my opinion, COVID, we had kind of a delayed reaction to COVID, and things are bad. Things are bad now based on the last 2 years of COVID, and the workforce issues have basically delayed everything with respect to manufacturing and shipping. And so we're essentially starting early and coming up with alternative suppliers and things like that to deal with it.
Thank you. And my second resource question is just for PacifiCorp. Since PacifiCorp operates in multiple states and has multiple teams and project management offices, and we're curious how PacifiCorp balances the risk of competing events in different states. For instance, if you had a major fire event in both California and Oregon, how would your grid operations center or wildfire safety teams address those events independently, and how would that impact each other?
This is Alan Barathan. I can take that for PacifiCorp because that's actually a scenario that we train for and plan for and set up structures in our emergency management office for how to handle if multiple emergencies were going on at the same time. Because you're correct, given a 6-state footprint, that is a possibility. And so we structure ourselves to be able to set up multiple ECCs and still have a coordination between various ECCs. How do we move resources around between our states to respond? So that is part of our program.
Okay, thank you. Andy and Adrian, I think that is all the questions I had prepared.
Well, I haven't seen anything in the Q&A since this morning, and no attendees have their hands raised. So I think what we'll do is wrap up now. James, can you go ahead and put on that last slide? Thank you. Appreciate it. So here's what happens next. We've got comments due by June 20th, and then the utilities will have until June 27th to respond to the comments. After that, on June 27th. After that, we get much bigger in terms of the timeline here. Our draft decisions are currently scheduled to be published for comment in August of this year. And then depending on the publication date, you'll have, regardless of the publication date, you'll have 20 days after issuance. And then the utilities will have the ability to reply up to 10 days after those comments. And then final decisions are expected to be posted in the fall of this year. And with that, I will call this workshop closed. And I want to thank you all for coming. And I hope you all got something out of this. So have a good day.